Welcome in, everybody, to the RAG Agents and MCP Best Practice Stack Workshop. We're going to get started building, shipping, and sharing. By the end of this, hopefully, all of you have built, shipped, and shared something like a bunch of legends. Okay, we've got a team here from AI Makerspace that are here to support you guys, and I just want to do a quick introduction, and maybe we can hand the mic around, Wiz, here. So I'm Dr. Greg. You may or may not have heard of AI Makerspace or our team before, but we love doing these kind of events. We're live on YouTube every week. In fact, we're going to be live on YouTube from this building about 15 minutes or so after this workshop. So check that out as well. And so I'm going to lead. The way this is kind of going to go today is I'll kind of be the maestro. I'll also go over the key concepts. And then the Wiz, aka the LLM wizard, as we like to call him, Chris Alexiuk, co-founder and CTO of AI Makerspace, is going to do the code. Then we've got Jacob over here, who's our course operations lead. We typically run courses online in a fully remote environment. It's quite rare to actually find us in person. And then John here is this 19-year-old phenom from Toronto who came out of a recent cohort and is building a product, soon-to-be startup founder. All of these people can totally help you out if you are struggling with code. We're happy to help you really dig in. We've got tons of resources everywhere. So Wiz, quick intro. Jacob, quick intro.
Hey, what's up, guys? So I'm Chris. You can call me Chris or the Wiz, and I'll be your shepherd through the code today, as well as the repo. If you have any questions of a technical nature, please let me know. I'm more than happy to help. We'll have some sessions where we kind of break out like you would do in a traditional Zoom room where we can actually work through some of the code. So that's going to be a great time to ask questions and dive a little bit deeper. And we'll pass it to Jacob.
Yep. Hello, everyone. I'm Jacob Kilpatrick. I'm the course operations lead at AI Makerspace. And so normally we do all these on Zoom, and so it's a bit different for me actually seeing you guys in person. So that's awesome to see. And again, if you have any questions or issues with the code, I'll be glad to help.
Yep, let me see that. And then we have also got Laura, aka Laura the Legend Funderburk, one of the earliest members of our community. She took a class with us many years ago at this point, and now she's part of the team. Tell them a little bit about what you do and how you can help them if they're interested in getting on that Discord and building community.
Thank you, Greg. Yeah, so I had a chance to join the AI Makerspace community right at the time they were founded. So I had a chance to meet Greg and Chris when they were teaching at Fourth Brain. And I've continued my journey of building, shipping, and sharing LLM production applications. So you can ask me anything regarding building RAG agents, anything you have, questions about the code. I'm very, very happy to help. I'm also leading community engagement and developer advocacy. So if you are looking for opportunities to talk about your product, I'm always looking for people to talk to and host on our YouTube channel. If you have any engagement initiatives with students, I'm also very happy to talk to you after the event.
Thank you, Laura. Okay, so that's all the sort of upfrontness before we get into the deets and the goods today. If you stick around all the way to the end, expect maybe a little bit more of the sell. But for now, let's go ahead and get into it. What we like to do each time we start any sort of session is to align exactly what you're going to get out of spending this time together. I really want to make sure we always respect every minute of everybody who comes and spends time with us, their schedule, and what they're interested in. So by the end of this particular session, this is actually sort of an amalgamation of a few different sessions we've done in the past through our courses and on YouTube. We want to make sure you understand what our picks are for the absolute best practice stack for production RAG applications. We're going to talk about orchestration frameworks, vector DBs, what's the number one thing you should always be doing after you build a simple RAG pipeline, how should you be evaluating these things, and what LLMs and embedding models, of course, what are the best out there today if you want to really go open source and get some privacy with your stuff. We're going to show you how to build, ship, and share one of these things. You can also build, he's going to also offer, you'll see in the repo, there's an OSS or an on-prem open source software edition. If you don't have a prem with you that can sort of run GPUs, it's not going to be something you want to mess with. But if you do have a sick prem with you, we can have people help you out and get that going. How to monitor and what to monitor. This is really important after you build a prototype and you're thinking about getting into production. Obviously, you gotta sort of really get down to brass tacks. What the heck do I need when I start building stuff out in my CSP? What kind of resources do I need and why? And of course, you need users in the first place to even be able to get some of those metrics. But how do we ship this? And what should we be thinking about? What do we hear from our enterprise customers? What do we hear from folks that are in our community about their problems? And it's really kind of interesting to see that cloud or on-prem really is kind of a false dichotomy, and we'll talk through that today. So what we want to talk about is first, quick introduction to RAG. Many of you are from different backgrounds. It's hard to sort of teach generally to everybody. So we'll try to bring everybody to the same place, but we will quickly accelerate into quite advanced materials. Just as a quick aside, this is only part 1, and this goes till about 10:45, first build session. Then we're going to dig into what the heck is an agent and what's MCP. So if you like the RAG and you want to get into the more advanced stuff, that'll be the second part of the session. Okay, back to RAG. RAG, the stack, building, operating, what are the pain points enterprise has, and how does cloud work versus on-prem? When you look at our picks for best practice tooling, how do they change when you move to a fully open source and on-prem implementation? Okay, so let's talk about RAG. Well, what's the point of RAG? The point is that we don't like when people confidently say things to us that are untrue. We don't like when LLMs do it either, right? This is the worst kind of person. Dead, bold-faced lie to you, looking you straight in the eye, right? This is not what we want from our LLMs. How do we avoid it? Well, we make sure that you say, don't say you know the answer. This is one of our core values at AI Makerspace. Embrace I don't know. We want our RAG systems to embrace I don't know as well. We want to give them the access to the knowledge that we want them to be able to answer on. We don't want them to be able to answer on everything generally. And so the idea of doing this fact checking is we want to find reference material, we want to augment our prompt with that reference material, and we want to get better answers. So the retrieval augmented generation of RAG is really what we're talking about here. Now, we're going to talk about sort of the simple, super basic RAG, which is dense vector retrieval added, and then you're putting stuff in context. So it's retrieval and in-context learning. Retrieval and in-context learning. Retrieval is not a new problem. It's not a new thing. It's been around forever. Search and retrieval is a problem Google solved in the first place. In-context learning is the kind of LLM-specific thing. Now, we don't have to use dense vectors today. If you look in vector DBs, there's all sorts of things we can do. It's easiest to learn from the basics, though. All right, so when we talk about retrieval, that's where we're dealing with vector embedding representations. When we talk about augmentation, that's where we're putting our stuff in context. And when we do the generation, that's when we actually complete the RAG system. So we ask a question, we send it to an embedding model. That representation of our chunked up question now in number format is going to go into our vector store. And we're going to say, what's similar to this chunk? What is similar exactly? We're going to find it. We're going to take it back out of embedding space. We're going to put it back in language space. We're going to pump that right into the prompt. And of course, there's all sorts of variations on this that people have done deep in the weeds. But we don't really care about any of those because we're talking about building applications that create business value. That's what we're talking about here. And this in-context learning piece is where we throw the goods into context. Now, finally, at the end, we do our generation, and we have RAG. So the idea of getting great fact-checkable input is this whole precursor before we ever use the LLM. Now, what could you do today? Well, you could go find and retrieve the stuff yourself. You could Control-C, Control-V, copy, paste it directly into the LLM, and you're doing RAG, okay? This is a way to automate the process of doing RAG. Now, here's a really helpful analogy. This diagram is super mid, first of all. Just this diagram is pretty terrible and pretty awful, and I don't want to be seen as somebody that puts this diagram up in his slides. But what I want to show you that's kind of interesting is that the way that we think about RAG is very similar to the way the initial transformer thought about doing things. So this idea of doing bidirectional encoder representations of transformers, this idea of looking both ways and really understanding the input, versus this idea of doing the generation, doing the decoding, doing the next token prediction. These are kind of part and parcel of what we've done with RAG, because this is kind of exactly what embedding models are. They're BERT style. This is kind of exactly what chat models are. They're GPT style. And moreover, what you can kind of think about is the encoder having been focused on understanding the input, using that understanding of the input from the encoder is what the decoder was always designed to do in the first place. So what we're kind of doing here with a RAG system, with a retriever and generator, is we're kind of not only getting great fact-checkable input from our retriever, but we're using it to understand the stuff before we pump it into the LLM. So it's the same meta pattern when we talk about RAG versus when we talk about the OG transformer. And so it's kind of an interesting thing that we're not really reinventing any wheels here when we talk about RAG. We're just sort of enhancing their usability. All right, so the idea of actually augmenting and putting stuff in context is the key to sort of all application development when you talk about AI engineering in general. In-context learning, of course, came out of the GPT-3 paper. Language models are few-shot learning. This is just putting stuff in the context window. So, you know, it's like if you give one shot, it actually does a whole lot better if the model's big enough. If you do, you know, 2-shot, 3-shot, 4-shot, 32-shot, oh my God, it gets even better and better. So the more stuff you put in context, the better it goes. Once you run out of context window space, you got to think about fine-tuning. If you care about any of this, if you want to go deeper into any of this, we have a whole open source course that we've put out, $19.99 value that used to be charged for people to take this course. But you can get this 100% for free on our website and on our YouTube channel. Also, if you want to look at sort of just doing a quick 5-day course to understand how LLMs work, we've got an email-based course for you. That's really not why we're here, though. We don't really care what happens behind the API. We don't. We care about hitting the LLM and getting a response. We care about doing search and retrieval and getting stuff back. And we care about putting together the building blocks, the Lego blocks, as Andrew would say, of LLM applications so we can put them into production. In fact, that's what AI engineering is all about. It's about the industry relevant skills. It's not about what happens at deeper levels, at layers of abstraction that we really don't care about any longer. The skills we need to build, deploy, operate, and improve LLM applications in production. And you'll see our definitions are often really, really focused on being application level and being production grade. So the stack is well described by this June 2023 article from A16Z, this LLM stack. And the stack, oh my God, I can't believe it, it's based on in-context learning, the meta design pattern. What should you put into the context window of the LLM? We still talk about this today. And there's a lot of different pieces of this, but really there's not that many pieces of this. In fact, to just get started, and one of the things that we recommend everybody to start with is just forget about most of this and to just focus on building a simple application. That is, building a front end, building a back end, hosting an application that uses an LLM. So vibe code it up on the front end, right? And make sure that it's super hype and legit. And you can do this with something like Vercel, and it does a fast API backend real quick, and you can use a simple model like GPT, the latest. And you can use just OpenAI Python SDK to do this. This is what we call the AI Engineer Challenge, and everybody that takes our bootcamp has to do this before they can actually enroll, because this is table stakes today. But that's not where it gets interesting. Where it gets interesting is when you have your data, and you're like, well, now I want to do stuff with this. And so what you can do is you can start adding pieces to the puzzle. You can start saying, I want to go from OpenAI Python SDK to something like an orchestration framework like LangChain. I want to actually leverage an embedding model that keeps my data safe. I want to actually leverage a vector store that's world-class and best-in-class. In fact, I actually want to leverage LLM that I can trust because I don't want to give my data to OpenAI, and I want to make sure that I'll be able to log and see what's happening behind the scenes. As the developer typically is going to improve these applications. And then there's a couple other pieces when we think about RAG in general. There's things like re-ranking. There's things like, actually, was that good? Do we need to change that in some type of way? Is there a specific way that we can use very detailed metrics to drive development? This is what's called metrics-driven development. And of course, where do we host our endpoints? And so we have today our best practice tools. So Wiz, let's talk about these. First of all, LangChain. Why? I heard there were other ones and they were dope too.
Yeah, I mean, there are other ones and they are dope too. I think at the end of the day, though, when we're talking about LangChain, we're really talking about something built on top of LangChain called LangGraph. And when it comes to composing kind of LLM systems right now, it is one of the best that exist. Realistically, right? You just need something to get started, and you need that something to help bridge the gap between your prototype phase and then when you want to be in production. LangGraph does that very well, very simply, and so that's why we see it there.
Yeah. So how come like not Llama Index, not Crew AI, like not AutoGen, not one of these other really cool ones? I heard they were pretty hyped too.
They are pretty hype, and I mean they're still good. And if you're the company you're joining is already using those stacks, then it's a great idea to continue using them. They're all using the same core fundamental patterns under the hood anyway, right? But with things like AutoGen and Crew, you're floating a little bit higher up in the abstraction, which is not always a bad thing, but it does mean that you have to dive in a little bit more than we're happy about to build kind of more complex or novel systems. And for things like Llama Index, it's just pick and choose. Llama Index has been focusing on different areas of integration, and not so much on the kind of composable framework in the way that LangGraph has. And so, if any company you join is using one of these frameworks, like that's great, just use it. It's going to be the same fundamental patterns under the hood anyway.
Yep. And if you want to talk more deeply about any of the stuff we talk about today, you can always find us during the break, and we'll go deeper into your specific use case. Okay, so let's keep it moving. Quadrant, they have sick swag. I like that about them. But why is this vector DB, besides the fact that they're the only one that raised money in 2025, actually the best DB today?
Yeah, I mean, there's a number of reasons that Quadrant is a great place to both get started and also kind of scale into. Number one, it is a service that you can choose management of, so you can use it yourself, or you can use their managed service. This is not true of all vector DBs. They have a focus on kind of speed and scalability, which means that when you get started with Quadrant, right, and you have hundreds of embedded documents, it's a really well matched vector DB. And then when you have billions of documents, it's still an excellent vector DB. So it's going to take you a very long time to never to scale out of what Quadrant's able to do reasonably quickly. And again, the flexibility of being able to choose the management as well as choose a number of other things in how it's implemented and how we interact with hardware, right? GPU acceleration, these kinds of things through Quadrant is just much simpler than it is on other vector DB platforms. So if you're using vector DBs, which you may well be using, right, then Quadrant's just the easiest place to get started and the easiest place to finish.
Yep. Okay. We don't want to belabor any of these points here, but best embedding model, I heard Ada was pretty good, but oh wait, I don't want to give my data to OpenAI, I got to go open source. How do I pick an open source embedding model? And why would we pick this one?
Yeah, so the name is not good, right? But it is a good embedding model. Yeah. It's multilingual. It has long context support. Embedding models these days are basically like, what budget do you have to host this model? And what do you want out of that embedding model? This one is a very comfortable balance between extremely good accuracy as well as being relatively small for the accuracy that it does have, as well as adapting to multiple languages.
Yep. And as we saw in the celestial mechanics of attention, sometimes, you know, you could use this embedding model, you could use that embedding model. It's like, what does your intuition tell you about what's going to be useful? How about you just build it, try it out, see what works. Moving on, chat model, Llama 3.3. How come not Llama 4? 70B, Instruct Turbo, we're going to do this through Together AI. Tell us why we're picking this model today.
Yeah, I mean, so this model is just still great. I don't think it'll ever stop being great, especially for RAG. So when we're talking about more complex agentic applications, we're not maybe reaching for Llama 3.370B as much. But we're talking about RAG. We're talking about, we have some retrieval pipeline and then we need to spit out answers. This model just cranks and it's 70B, right? 7 billion parameters. There's quants. You can run this thing on like a toaster. And crucially, it is not the unfortunately less desirable Meta Llama 4 models, which they require a big footprint that 70B does not require.
Okay, so how many toasters would we need to run 70B?
Well, on the right, I'm sure Unsloth can run this thing on one toaster.
Okay, on the slot, you run on one
yeah.
toaster. Okay, heck yeah. So when we serve these things up, you got to follow up?
Sir, yeah, quick question on the Llama 3. So we are not going with Llama 4 due to the problems it has faced.
Llama 4 requires a bigger memory footprint. It's actually great when you need to have that really zippy inference and you have that capacity, but before you have kind of like a lot of GPU weight in your organization to spend on that capacity to get that serving speed, it's just not, it makes no sense at all to use the model when it is not going to outpunch, your RAG pipeline will not be bottlenecked by 70B. It'll be bottlenecked by retrieval pipeline, and so using like a huge generator is just not going to give you the gains that you want.
Yeah.
Just wait for the OpenAI. Model.
Yes.
Yeah, open AI to do some open AI, right? And so we've got also the Llama 4 model, for those of you that don't know, it's a mixture of experts model. So part of the issue is you have to load all the experts into GPU memory before you can actually do inference. And you can just avoid all of these types of architecture-specific issues with Llama 3.3. Together AI is just super quick to set up, reliable. We found it to be pretty good. Anything else to add here?
Nope, it's fast.
Yeah, okay. Lots of ways to serve models, lots. If you're into that, we can chat more about it. Ragus, our boys over at Ragus, YC Winter 2023, I think. The RAG assessment framework, they were kind of leading the way early. They've got world-class metrics. They only do this, importantly, like all the other we promise you the world and go fully end-to-end platforms and clouds. This is the one we use. Talk a little bit more about this.
I mean, really, we could say like the only RAG evaluation framework that has any amount of credibility. Ragus is just the people that are doing this job. It's a thankless job, but they're doing it. If you look across the industry and you look at other frameworks that offer RAG evaluation, you'll find that at best they've renamed a Ragus metric and have served that. They just they set the tone for RAG evaluation. They're continuing to do so for agents. Ragus is the RAG evaluation framework.
Yep. And then last two, Cohere re-rank. Always use a re-ranker when we do RAG. Hot tip. Always re-rank. First of all, why and why this re-ranker?
Yeah, I mean, re-ranking is, so like, when we talk about, when we hear the word RAG, I think a lot of people have this image of we're just going to do dense vector retrieval, and we're going to shove stuff into the LLM's context. We are still, of course, doing those things, but things like re-ranking is just table stakes. Basically, it lets you make sure that the LLM sees the correct context, or the most correct context possible. And why Cohere? I mean, Cohere is, first of all, Canadian, let's go. Second of all, I mean, they may not have the best LLM, but they do have the best re-ranker. And I think they'll continue to have the best re-ranker for eternity. So.
Oh, eternity, nice, okay. And finally, Langsmith, we're in the LangX ecosystem. There's other monitoring and observability tools, but we're gonna stick in this ecosystem. Any other particular reason why Langsmith?
Yeah, everyone else has built, reasonable approximations or clones of Langsmith, but at the end of the day, Langsmith is just kind of, again, they were the first people to present information from these LLM systems in the format that we're now, seeing as ubiquitous. And again, it's tightly integrated with the LangX ecosystem, so we're using LangGraph, may as well use LangSmith.
All right, we're going to be smithing some Langs. Thanks, Wiz. All right, so what we want to do is we want to take this idea of RAG and we want to be able to build it out. Now, to build it out, we can start breaking it down into some of these core components that we're going to need to do a simple LangChain RAG application. It's actually gotten quite easy to put this together over time, and the simplest RAG application actually uses a higher level abstraction today. If you go into the LangChain docs, they're going to use LangGraph out of the box. We'll talk about that in just a moment, but this is kind of the way each of these pieces might fit into our mapped puzzle here, with the Llama 3.370B being the generator, with the embedding model over there, both hosted on together. Cohere is sort of used for re-ranking, and so on here. So, building a RAG app is what we want to kind of do next. Now, we want to pick an application that it's sort of contrived, because you sort of must be when you're not actually running something that people are using in production. So we're going to do a potent quotables thing. Now, the reason for this is because it kind of, and we're going to do it with at least two different sources. This gives us another layer of data richness, data about the data, metadata, that we can use, because that's really actually important when we're doing chunking, when we're putting stuff into our vector DB, so that we can do retrieval really well. Because as goes retrieval, so goes generation, and of course that's through prompt augmentation. And remember, it really does come back to the data. The data is the gold, and if you, what AI is exposing is, it's exposing that you did a terrible job setting up your data during your digital transformation and your AI transformation. It's exposing that, because if you did a great job setting that huge monolith up, you'd be able to retrieve steps super easily, and people just can't. And this idea of putting stuff in a vector DB, it's just chunks. That's just breaking text into small pieces. Now, of course, there's structured data, and there's semi-structured data, and there's multimodal data, and there's all of that. Again, let's start simply here. Even just text data, though, you can have data about the data, right? Metadata is really important information that we can use to enhance our ability to retrieve. Now, think about the enterprise. What's the enterprise? I got a pile of docs here. Throw it into the long context window LLM, it'll solve my problem. Oh wait, no, probably it won't. But if you actually find a chunk that you like, one of the questions you might ask is, well, hold on, wait, what doc was that chunk from? What author was that quote from? What additional piece of layered information might I want to know about this? And of course, this goes back to, well, what questions are you asking, and how do you set up your data, and how does the product management work, and what was the problem you were solving in the first place, and who were you solving it for, and all that's really important. You can dump just all the data, and you will get an answer, but is it hallucinating? Were you hallucinating when you set up the problem statement? These are all good questions, but this is a huge problem. You can't just dump your data and have magic happen. That's not how it works. So when you're chunking, when you're setting this up, you want to start thinking about this idea of just doing chunking is sort of inherently tied to retrieval. And so when you're doing both of these things, you kind of need some additional information. Some like metadata is often super helpful. You can follow this metadata into your vector store, and you can use it for retrieval, because both chunking and retrieval affect what we put in context. And so when we have data, we want to have as much metadata as possible to help, because we can optimize that metadata to really dial in what we're doing and we're putting in context. Because again, it's just retrieval and putting stuff in context. This is not a new problem. Yeah?
Can we use the LLM to create metadata?
Oh, absolutely, 100%, yes. And that sometimes is in fact, some of the more advanced techniques are doing slightly just that today, yeah.
Is there any kind of method we can use for getting the semantic relationship between the chunks?
Oh, 100%, yeah, and there's all sorts of additional chunking techniques, and we're happy to point you to some of the other events we've done on YouTube before, like what semantic chunking does is it'll take the 3 separate chunks and it'll look, how similar are these, and it'll say, if you're really similar, you go together into one chunk. And then if you're sufficiently different, you should be chunked away. Now, of course, That takes additional embedding model calls, that takes additional compute costs, that takes additional, stuff away from you being able to do this efficiently. So, is it worth it? Well, it depends, right? Embedding can be quite expensive, especially if you're doing it on a lot of data. So yeah, these are all the right questions to ask, and data is a very rich topic, but in the end, what we can see that the stack is pretty straightforward. And what we're gonna do is we're gonna go ahead and build, ship, and share this RAG application for you guys today. So Wiz, you're up. We're gonna see the LLM wizard here walk us through the best practice RAG stack 2025.
Alrighty. So basically, what we're going to do is we're going to set this up, start to finish in a notebook, and talk through kind of what each piece is doing. Yes. Okay. Just wait for the screen to come up. Perfect. Okay, and we'll zoom in a ton. There you go. Okay, so a couple things. This is obviously the notebook. You're welcome to implement it in whatever form you enjoy. If you just want to throw this all into an app.py and wrap it with whatever your favorite web framework is, or LangServe, whatever you happen to do, that's totally fine. But the idea is that we're going to just demonstrate how to set this up. Again, there are two versions of this in the repo. You can find the repo at bit.ly/tmlscode2025 on the whiteboard over here. And the idea is that we're gonna work through some proprietary models in this selection, but we are not going to work through any kind of open source notebook. That is available should you want it though. Okay, so first thing we gotta do is, of course, because we're using proprietary models, we're gonna shove in a bunch of API keys that you'll be able to get. So this is Together, Cohere, and NVIDIA API key. There you go. You can find those at their respective websites. If you really want to do the open source version of this, again, you can use Arise Phoenix. There's an example of that in the other notebook, but we're going to stick with Langsmith. You can pay Langsmith to be run on-prem, right? But for free, it is the cloud version, and you're paying per trace at some point. So do keep that in mind. If you scale this into production, this is a cost that you're going to incur. But if you need it to be secured on-prem, they will happily take your cash to do that. So that's what we're going to do. The first thing we're going to do is we're going to, just take in a bunch of documents. This is not a standard process. So this is what it looks like for this particular pile of data, which we can look at. In this case, it's just a bunch of quotes from Da Vinci and Thoreau. So that's what it looks like, right? But your data may look very different. It may be, PDFs, etc. Whatever it is. The idea is that there isn't like there's not a method that you can import that is like cleanly ingest my data method, right? So what you should do is explore your data, understand the data, and then use that to inform both your ingestion and chunking strategies. Back in 2024, we used to lean heavily on things like recursive character text splitter, and we will see an example of that coming up, but the idea is that for most cases, the best practice is to understand your data and chunk it accordingly, right? So we're not going to recommend, like, this is the best chunking strategy. In this case, we just load stuff up, we split it, we know there are a bunch of quotes, so we can split easily on new lines. And then we have to do a little bit of cleaning, right? The quotes, as we can see here, come with all kinds of extra characters that we really don't care about. We don't need these numbers. In fact, we really don't want these numbers. It might confuse the LLM, right? If we give it context and one of the quote has a higher number, that's imparting information into our context that means nothing and we just don't want. So we clean our quotes, and then we need to embed. Again, we're going to be using the Llama 3.2 NVEmbed QA1BV2 embedding model, which is available at build.nvidia.com, and we can import it like we would any other embedding model in the LangX ecosystem. There's already a wrapper for this. It's maintained by both Loughnane and NVIDIA. There you go. You'll see as well we have this truncate equals none. What this means is that if we shove too long of context into our embedding model, we're going to get an error back instead of doing some kind of truncation, right? So you could, if we shove like a whole book into the embedding model, right, which has an 8K context window, we could elect for it to automatically truncate starting at the beginning or the end, right? So just chop off every extraneous character or only leave the last 8K tokens. In this case, though, we're just going to say if it's too long to throw an error. Spoiler alert, none of the quotes are very long at all. Okay, so we embed it. We see the size of our embedding, right, 2048. The size of your embedding does matter. You know, this is something that I think wasn't thought a lot about when RAG was first storming onto the scene, but is very important now, right? It doesn't matter when we have 100 quotes, of course, right? 2048 is who cares. But when we have, you know, into the millions and billions of documents, suddenly a billion of anything that's 2048 is going to be huge, right? And so the ability to use smaller embeddings is very important. And a lot of embedding models, including the one that we're using today, implement something called Matryoshka embeddings, which allows us to shorten the embeddings, right? So instead of 2048, maybe we find that we get good enough performance with, you know, like 512, right, length embeddings. The idea being that this number isn't just like a nothing burger anymore. We should care about it because it directly translates to cost through whatever our storage mechanism is. But for now, again, we're just going to run this on our laptops, right? So it's not a worry. The next thing we're going to do is create our vector store, which is going to be Quadrant. We're going to do this in memory, right? This can be pointed at basically any kind of thing that holds or houses data. So we're going to use our laptops, you know, RAM today, but you can use anything, SQLite database, some data lake, Databricks, whatever you want, right? You can just hook this in. This is, again, a decision that people weren't thinking a lot about in ye old days of 2024 and 2023, but you know, it is something that's important today to consider. Where does this vector, you know, live? How quickly can I load it? How quickly can I access it, right? And of course, how much does it cost? And spoiler alert on that one, the faster you can access it is generally related to how expensive it is. To create this, we're going to create a collection. A collection is kind of like a separate index inside the vector store. So one vector store could have many different collections inside of it. In this case, we're just calling it, you know, this easy collection, quote collection, and we are manually setting up our size as well as indicating what distance we want to use. Of course, we're using cosine similarity because that's just a great one to use. You know, there you go. But Quadrant is taking care of things like approximate nearest neighbors for you. It's taking care of making sure that vector lookup is quick, that it's not slow, right? So that's one of the reasons why we suggest it. It's going to handle all of this for you on the back end so that you get your vectors as fast as possible. When we actually set this up for the LangChain side, we have to point to the client we created for Quadrant, what collection we want to use, and then our embedding model. It is still crucial in 2025 to make sure that you're using the same embedding model to embed your documents as you are using during RAG. They must be the same. There's been a lot of research that says we can actually splice these embeddings, and so you know, you very technically don't literally need to use the same embedding model anymore, but the engineering behind not doing that will make you very sad. So we're just going to continue to do that for the foreseeable future. Then we just shove stuff into the vector store. We're going to impart some metadata here that Greg was talking about. This metadata is helpful for us to understand what is sourcing the information or what source the information came from. This is, on the surface, it would seem a little bit useful because it might indicate like who the quote is from, or you know, act as additional context to the LLM. But beyond that, It's useful because we can use this to help filter things, right? We can use this in a programmatic way in order to understand more about our vector database or the vectors that live within it, so we can retrieve more efficiently. Metadata is a very important piece of the puzzle. It's not something you should be sleeping on for sure. But other than that, we just shove the documents in, and we do the same thing for our Da Vinci quotes. Again, using this metadata to impart additional information so that we can filter later and do all kinds of cool, fun metadata stuff. Finally, we're going to use a retriever. You'll notice two things. Number one, it includes re-ranking. Number two, it's hybrid retrieval. You know, the RAG is dead memes on social media platforms are funny, and you know, you love them. They're good for a little laugh emoji or whatever. But dense vector retrieval is still pumping along. We just would never recommend just dense vector retrieval. I think that we've learned our lesson through the last 2 years. And so at a base level, we're going to recommend that we combine these dense and sparse methods. We're calling BM25 here keyword search. But the idea is that we know that this hybrid approach is going to, in almost all use cases, be beneficial. And so we're just going to recommend it whole cloth across the board at all times. And then, of course, re-ranking. Greg talked to us about re-ranking. But the idea is pretty simple. We can slowly comb through a few results to be really extra sure that we have the right context versus using these very fast but perhaps slightly imprecise methods of retrieving context like our dense and keyword retrieval. So to set that up, you know it's not that hard. Well, let's go. So what we're going to do is we're going to retrieve 5 pieces of context from our BM25 retriever. We're going to also retrieve 5 pieces of context from our vector store or dense vector retrieval, and then we're going to weight those 50-50. Each of these numbers that you see, right, so K for BM25, K for the retriever, and 0.5 for weighting are hyperparameters. They're worth playing with. Changing them will change how your system responds and how it works. So it is worthwhile to spend time to try to make these numbers correct for your application. Please just use these as guidance. They are in no way absolutely recommended for all use cases. Just somewhere you can start, but you should be searching through some combinations of these numbers to find the one that gives you the best performance. Re-ranking is pretty straightforward. We basically just want to have some target that we wind up with, target context. This is going to be based on a number of different factors, like how well our LLM handles long context, right? You know, how much context we want to shove in. What is the actual individual size or average size of our potentially retrieved context, right? So again, this number is something that you should play with. Basically, if you see a number here, this is something that you should be playing with. And we'll discuss how you may evaluate the system in order to make that playing a little bit more informed than just vibes. Finally, we have our RAG prompt. RAG prompts are still useful to think about in 2025, right? We're not beyond the point where like you should just always use this prompt and it's going to be perfect every time. This is still independent to your use case. This is again something that you should experiment with, something that you should find your favorite approach for. You can go from just using a playground and you know, doing kind of manual prompt engineering all the way to using something like Dispy to take a more systematic approach to finding the correct prompts. But at the end of the day, we still fret about these dang prompts in RAG. You know, there is a best one for your use case, and it's probably not that one. Okay. Finally, we can get our generator online. Hot take of this year, 2025, the generator is so completely the least important part of the puzzle for RAG. It was also true a while ago, but I think people have accepted it and internalized it more these days. We just need a generator that's good enough, right? In reality, RAG is very much like if we were to look at the importance of each piece by the size of the letter in the acronym, you know, R would be the size of the Empire State Building, and AMG would be like the guys walking on the street underneath the building. Retrieval is the most important part. We just need something to generate text once we've retrieved the correct context. LLMs are super good at answering the question correctly when they have the answer in their context. Even if the context is a little bit long, that is still true. So we need a generator. It just has to be functional and it has to listen to us, which is why we use a great instruction following model in Llama 3.370b instruct. Okay, so now we can use the LLM. What did Thoreau say about the importance of solitude? We do expose ourselves a little bit here by looking at the fact that the LLM does have some knowledge of these extremely famous old quotes from extremely famous people. It's not like the LLM's never heard of these dudes before, right? So this is something that may or may not be true based on your use case, and it may or may not inform some steps that you may need to take with your generator, like fine-tuning it for your domain or doing any kind of domain adaptation in the system otherwise. Finally, we can create the graph. So this is the line graph part. Basically, we start with some state. The state is easy in this case. It's question, context, and response. This can be as complicated as you need or as simple as you need. State is something that you get to choose what happens to it during the flow of the application. So make this as crazy as you want or as simple as you want. You can add things like metadata and timestamping and tokens, all kinds of different information here. State is basically the thing that we're going to do work on as it moves around the graph, right? Finally, we have our first node. So we're going to go ahead and we're going to have this be our retrieved documents. And you're going to notice, the Pythonistas among you will notice that we have this little ::-1 notation, which you may know reverses the order of a list. This is a quirk of Llama 3.370b. It is going to look at the last piece of context with the most rapt attention. And so we reverse the list so that our most important retrieved context is the last thing that it quote unquote sees. Not to anthropomorphize too much, but the idea is that these kinds of things, these little tiny adjustments, right, can be impactful in your system. So while we're giving you like boilerplate framework, certainly there is so much you can do here, very rich space. Generating though is easy. We just shove stuff into the context window and we ask the model to produce a response. And then we are going to actually build our graph. We start from a blank canvas of our state. And then we add, in this case, our nodes in a sequence. This is because RAG does not require any dynamic, application flow. It simply goes from start to finish. We retrieve context, and then we generate a response. There is no ordering issue here. There is no alternate order. That's it. That's what we do. And then we start from the start, and we immediately go to retrieve. That's our graph. We can deploy our graph's mermaid plot. It's beautiful. It's simple. It's RAG. You love to see it. There we go. Finally, we can test it. We can test it with some things that should not be answerable. Like we know that neither of these philosophers philosophized about why it is that birds do their singing. And so we can ask, why do they sing? And we get, I don't know. We can say things like, what did Da Vinci have to say about solitude? And because we've added metadata that indicates which author is which, Da Vinci didn't say anything about that in the quotes we provided, at least. I'm sure the guy yapped a lot, so he probably said something, but certainly not in our data set. So we get the very coveted I don't know. We can look at the contents and see that Thoreau did say stuff, right? Like he's on the map here, but we are simply not going to indicate him because our prompt asked for Da Vinci, not Thoreau. Present documents, so this is something that should be there. Again, it answers the question very well. And then we can do like the fun thing, which is that we can ask a question that has to do with both of these gentlemen, and we can get back some comparison from our LLM that synthesizes the two together. Finally, we have evaluation. Basically, you just plug and play Ragus. We have an example here where we're going to use OpenAI as our judge LLM. And we can actually judge this based on fully answered. So the quality we're trying to measure is if it's fully answered. We describe it by saying verify if the question was answered completely. We can have our LLM judge if that was the case based on the answer and the query. So basically our LLM judge is going to look at the query, going to look at the answer, and it's going to say whether or not it feels as though the RAG pipeline did a good job. In this case, we get a 1, which means the LLM judge thought that it did a good job. This is just one example of how to use Ragus. We have tons of events in Boilerplate for how to use Ragus more and how to leverage it for more in-depth or more complex metrics. But in this sample notebook, we're just showing you Ragus is good. You should always be using it. And this is the thing that you would use to choose the best numbers, right? So if you want to choose the best weightings for your hybrid retriever, Ragus is how we would do that in a way that actually says it's better now, right? Or it's worse now. There you go. So that is it for the code. With that, we'll pass you back to Dr. Greg.
Ooh, oh my goodness, that was so much, Wiz. Wow. Round of applause for Wiz, real quick. Yeah. Okay, guys. So, how many people are feeling great about the code that he just shared? Oh, okay. That's a lot. Are you guys lying? That's awesome because our community is really, really focused on people that either code every day or that want to code every day. So if that's you, maybe the community is a really good spot for you to start building, shipping, and sharing today. This is going to be just a little getting used to here. Let me do it like this. And I think. And but we're gonna actually switch gears because that was a lot, and there's often so much richness and depth that we don't get to go into. This way, here we go. So let's think about the stack we just talked about, because really what he just did is he went through all sorts of stuff that I didn't introduce you to at all, literally. I didn't tell you about any of the ways any of these things worked, but he just powered through. So if you're a builder and you don't really care how it works and you just want to build, that might be good for you. But for the rest of us, it's probably not so good. And so, although we can build it like that, the thing is that there's actually a lot of richness and depth that was missed out on. So if you want to learn how LangChain or LangGraph works under the hood, if you want to understand what some of the things that are baked into the framework that make it production grade out of the box are, if you want to understand how to, like my man back here, do some more advanced things like semantic chunking, if you want to think about how Ragus actually works, what the core constructs are, what the real metrics are that we're using and that we're leveraging, how that process works, if you want to understand how to actually think about additional retrieval strategies beyond re-ranking, if you want to think about details about how Langsmith works, all of that stuff is totally available, and we have code for each one, but each one takes an hour at least. And so we just, I don't know how much time today. And the thing is like, we want to be practical and we want to be useful. So all these details are cool, but in some sense, they don't really matter nearly as much as what's your data and what are you building and how quickly can you get something like this repo spun up to show your boss or to show your customers. And so that's really what we're focused on. We do have lots of ways to go in depth on this. If you're like, oh my God, there's no way I could self-study that. Oh my God, have we got a solution for you? The 10-week AI Engineering Bootcamp. You want to learn more, check us out, or talk to my man Lusk right over here. If you buy the 10-week Engineering Bootcamp, it's a thing that basically we give you access to experts that help you not just have accountability, not just be in a group of people, but that actually it's going to be the most robust breakout room experience you've ever had, because they're all facilitated by experts that we've trained up ourselves and that have really bought into the education of the future. So this is a little bit of a snapshot of where people were, where some of you maybe feel like you were in the middle during that little talk, and where they got to over the course of 10 weeks. People like Cam, people like all these folks. This is literally from 5 days ago. Demo day was a few weeks ago for the last cohort. And so if you want to build stuff like this, we can definitely help. You don't have to pay us to get any of this, though. You can check it out. You can join our community. Shout out to Laura. You can jump in. You can start building, shipping, and sharing today. The way that we recommend to get started, if you want to get to LLM Wizard level, is complete the challenge. That's going to make you set up your dev environment. That's going to make you deploy your first LLM application. So, okay, zooming out. Okay, Wiz, let's say I'm done with this now. okay, so I built my RAG app, I got some users, and now I have this thing, and I'm on the back end, I'm looking at it. What am I even looking for exactly? What should I be monitoring and logging exactly after this thing is set up and people are using it?
Yeah, I mean, so this is going to be largely handled through the actual physical process of the monitoring and logging is going to be handled through whatever observability framework you're using. So in this case, we're recommending Alexiuk. The idea is that you should be caring a lot about things like your latencies, right? What is the average latency? What is the latency for the 1% of people who are just having to wait a long time, right? As well, you want to make sure you are continuously evaluating the responses generated by your LLM. A lot of times what happens is that when we build an application, right, for our users, we have this expectation of things they're going to try to use our application for, and very quickly they'll be either very bad at that or they'll do something completely and totally unrelated to what we designed the tool for. And we have to be able to know or see, when that's happening and why, so we can make adjustments to the entire system. Potentially better instructions, potentially actually changing the application itself. This is all something you should observe through that framework like Alexiuk. As well, we should be capturing user data, right? So you love the thumbs up, thumbs down. A lot of people engage with those systems, but people who have very bad times usually do, right? And so it's good signal to see, what's causing your users to have negative experiences, and that is worth its weight in gold.
That's right. So start setting up your AI engineering customer service department. That's always the most fun part of building any product or business. And that's going to allow us then to really, when we go, we say, oh, now I want to put this in Azure. Now I want to put this in production in my company. Now I want to put this in AWS. Now I want to put this in GCP. It's going to allow us to say, well, hold on. I was measuring these things, and these are the important things, I think. And engineering team, I know I'm just a lowly AI engineer. I'm a lowly data scientist. I'm a lowly MLE. But I think I understand some stuff about ops. This is what I think I should be measuring from users. Is this right? Can we work together? This is sort of the AI engineering approach that is just so good sometimes, because you can say, look, I don't know everything, but I know enough, and I've done enough. I have proof of work on stuff that I measured from my users that I think is similar to the stuff you guys measure today on production applications we actually have. So how do I start to develop this sort of baseline of how much compute, how much resource, what kind of P99, what kind of time to first token? How do I start to move through this process of how do I make sure this thing is secure? How do I make sure that oh my God, the headache just spins out of control? Getting into the CSP, what brass tacks? How do we get into the CSP from here?
Yeah, this is something that either you're forced to do, or something that you will, I hope, depending on the size of organization, simply never have to think about. If you do have to think about it, if you're one of the lucky few who gets to wear the ops hat while you wear the application hat, then I would say this is all about right sizing, right? So this is about understanding, things about your GPUs. So how many requests are we getting per unit time? How much is a GPU saturated? These are things we can get by monitoring our usage through something like Together AI, right? If we see that we're always getting slammed with a number of requests, right, and we're able to determine that means we'll be able to saturate N GPUs on our CSP, then we can move to that. In reality, this is going to be a decision that's motivated by a number of different teams. You're going to be responsible for informing what kind of capacity you need, or at least sharing that information with teams who are procuring these resources. And if you are procuring these resources, then these all the cloud platforms offer effectively serverless, implementations of either models themselves or GPUs, or you can pay the big bucks and get some instances from like AWS, and then monitor utilization and right size from there. You are not going to get this right on the first try almost ever, but you will be able to, after taking the first swing, you will be able to monitor and collect information that allows you to get it right on the second and third tries. Remember, when you're making this switch from other people are hosting this thing to we are hosting this thing, it is going to be a shock in cost until you figure out exact right sizing. And even then, because a lot of these companies are incentivized to operate at very small margins, or because they're able to spread cost across a number of users, you're likely going to be paying more, and that's a conversation you're going to have to figure out how to tackle with leadership. Unless you're leadership, in which case, it's easier.
Yeah, yeah, and I mean, it's an interesting point here. These serverless solutions that the CSP platforms have, like maybe that is good enough for your team today if you can actually get access to it and use it to build quick RAG prototypes and build quick things up and get them to users. But fundamentally, the serverless solution is kind of the AI engineer role automated, right, Wiz? And so we kind of have this idea of you can pay extra bucks for them to do it for you, and you can slowly but surely start to do more and more of it yourself as you're able to hire more technical talent onto your own team instead of outsourcing it to the CSP.
Yeah, I think so. If you're into the AI ops or LLM ops style roles, absolutely that's true. If you are a pure-blooded AI engineer, then I surely hope this does not become your main responsibility.
Yeah, unless you really want
Unless
to
you love
move
it.
into ops.
Unless you
Yeah,
love
yeah,
it.
yeah. Speaking of sort of after the benchmarking, this allows us to sort of move from an on-cloud into more of an on-prem setup. Now, when we do this, we want to bring it to our local prem here, or wherever we are exactly, wherever our premises may lie. There's a number of changes we've made here in pink. So let's walk through these real quick, Wiz. One of them is Arise Phoenix. I still see Quadrant. I still see the same re-ranker. I see a different LLM, or I see an open source re-ranker, because of course we can't, in an air-gapped environment, use Cohere's API. And then endpoints, I have this NVIDIA NIM thing. Can you talk to us a little bit about monitoring the vector DB, re-ranker, and endpoints?
Yeah, basically these are the same parts that we used before, or very close to the same parts we used before, but we're able to run them on our machines, right? So obviously we can't use Together AI because Together AI is not on our machine. That's an endpoint, so we have to replace our LLM. We've chosen Quen 3.4TB via Ollama, largely because everybody can run Ollama. Is this like the highest production grade, production quality endpoint solution? Probably not. To get started with the POC, absolutely yes. Monitoring Rise Phoenix. They have the best Langsmith clone that exists on the market. They have been doing monitoring forever. It may not look pretty, but it surely works. It's very easy to spin up and maintain. We still use Quadrant, but we're on-prem. We're probably not wanting to throw away all of our RAM. So the in-memory vector store is probably not the solution. So we're gonna spin it up in Docker. We're gonna let it use our file system, which is gonna allow our RAM to not be wasted away holding many 2048 vectors. Re-ranker, it's actually the Llama 3.2 NV re-rank instead of embed QA 1BV2. It's just a great open source re-ranker, and it's available as something called an NVIDIA NIM, which is basically a Docker container that you can spin up, and it serves the model with the appropriate backend. You can also use things like VLLM or SGLang or whatever you want to use. The recommendation for NIM is that it's going to automatically select an available and tested backend, so it's just easy to use. Yeah.
Perfect. Thank you, Wiz. All right, let's go ahead and switch gears again here because I think we want to kind of zoom out for a second, okay? For those of you that are kind of getting the eyes glazed over in here, I know not everybody is as deep in the weeds as our CTO here. We asked our community, and I asked a bunch of business leaders, including one large bank. Let's talk about that since we're in Toronto. It was a bank from the US, by the way. like, what's really going on? What are people like really concerned about? Is on-prem really a concern? Are some of these model selections really a concern? What's really going on? I said, hey, I'm looking for insights into the biggest pain points when it comes to building a proper AI engineering team, the kind that basically builds, ships, and shares like a bunch of legends, right? What's the deal? What are you actually seeing out there? And a lot of people are struggling with their team. Everybody's saying, "Oh my God, I can't hire my way out of this anymore because there's nobody to hire. I got to take a hybrid approach, right? Hybrid training. Maybe you need to train people. You need to train people. I don't know. Maybe you could come talk to me. But this is a big problem, and the additional types of problems we're hearing from people is, man, it's just like it's so slow to even get one POC done. It's like pulling teeth, It's like, and there's different reasons for this, and there's technical solutions to each of those reasons. Things like tooling, people are always, and this is the build versus buy thing. Do I need to buy, because I got people hitting me up all the time because I'm in a business role. I got people like, buy my platform, buy my platform, buy my platform. And sometimes you're like, oh, that actually looks like it'd be kind of cool. How do I make the decision on whether or not that's actually useful for my team or not, right? And so this is like, I want the best, but I want to pay the least. Performance versus efficiency trade-off 101. Of course, we're hearing also, the security folks, the reliability folks, the compliance and risk folks. These guys are really junking up the pipelines these days. And it really does add a lot of overhead to trying to get really what is kind of much simpler technical problems done. And moreover, if we dig deeper, we can ask people like, well, so what's the deal today with what you're actually doing? And like, really, are you using the cloud? You say you want to use on-prem. What does that even mean, first of all? And then where are you headed? I know that's where you are today, but where are you headed? What we're hearing from people is that people are like, hey, I wanna get the best of everything. I want to maximize ROI. I want to have a flexible way to do this. I have lots of projects I want to do, but they're sort of at some point along the way they're not making it into production. They're not making it into whatever my production system actually means today. And so what we'll hear from people that have on-prem or do some on-prem is we'll be like, yeah, well, I mean, our data is PII data. We just can't give it to the models. We can't trust anybody. We have to do everything on-prem. You don't understand. It's going to be 18 months. It's going to be super long. I talk to defense contractors, and they're like, hey, I guess Azure, Fed Cloud is coming, but it's going to be 18 to 24 months. It's like 18 to 24 months. Oh my God, that's insane. We talk to the banking industry. They're like, yeah, I mean, well, historically, we've always done everything on-prem, and so, but we have this infra team over here. We have this app developer team over here. We have this data science team over here, and they all need to know the same stuff that all of them know, but only they know the things that exist in their departments today. So what the hell do we do? And it's like, wow, we just bought a pile of GPUs and they're not hooked up yet. It's like, yeah, I mean, that's tough. What are you doing today to ship apps? You can't wait 18 months, especially when you're feeling that heated competition, which not every industry is, but certainly banking is. So this is a hard problem. This is a hard problem. So let's take a look at it. We're deep in it depends land here. This is the problem. You can't talk about this in general. You have to talk about it in specific. So this is a large bank. I won't name the bank, but the bank's biggest blocker is integration maturity, right? They have new hardware. They have new things that they've built, but everything's siloed. Everything's limited. People don't know. The data science team doesn't know about the GPUs. The app developer team doesn't know enough about vibe coding and hosting on the back end, and actually what the data is that needs to go into it. Then you have all these data stewards and SMEs over here that sort of won't let you touch their stuff, and there's all these. It's rough, and we're hearing things from this particular bank like, I just wish I could go faster. And ultimately, what every single company that I've talked to says is they said, well, we do this today, but we're going to do this tomorrow. We're working with Azure, so we can do this tomorrow. We're working with AWS, so we can do this tomorrow. This tomorrowness vision of the future typically exists in the cloud as much as possible. And of course, on-prem is just your own private cloud. But moving from where we were, where the industry kind of lived, the industries are different too, whether you're in healthcare or banking or defense or whatever, to where we want to go is a really painful transition for everybody. And, you know, everybody ultimately is using some combination of on-prem and cloud. The thing here that's important to understand is if we dig deeper into on-prem and cloud, we can think about the cloud production deployment process for a particular tech company in the San Francisco Bay Area. This is the kind of an older company, one that you may have heard of that is deep in the PDF game. And the idea of like, how do you actually do stuff there? This is from folks in our community that work at places like this, that have been doing this for the last 2 years, right? That have been working their way slowly through the tough slog, is like, you have to develop some sort of POC first. And on-prem could literally be like, this right here is my prem. Hey boss, come look at my thing, it's on-prem, right? And in fact, that's the way the best companies are doing it today. And yeah, of course you need a GPU. If you have integrated, you know, GPU hardware on the newest Mac, you can kind of get a lot done. Now, you need to connect to the internet to download some stuff, but then you can, after you get the data in, you get the open source models in, you're self-hosted, right? You got a vibe-coded app up. Now you air gap yourself, and now you say, oh, look, I got my localhost app, and I can walk into my boss's office, and I can be like, yo, check this out. Play with this, right? This is cool, right? And it took you what? It took you 3 hours. It took you an afternoon. It didn't take you 18 months. It didn't take you 24 months. It might take it 24 months to get into production, but can you walk down the hall to an internal stakeholder that's the real user here? Yeah, I think you can, right? And it's like, this is the thing people are sleeping on. And if you want to make 200K today as an AI engineer, you can by literally just doing this everywhere you go. And then you can demand 300K and maybe I don't know, 100 million from OpenAI soon. Or, I don't know if you guys saw this. But like, you can, it's insane what people will pay for this acceleration of development velocity today. 200K is a drop in the bucket. And so if you have the skills to do phase one, then you have to have the patience and the buy-in to that particular company to do phases, you know, basically 3 through 5. But the way this works is, you get the on-prem demo done. You get the boss to say, yo, that was dope. Let me let you, you know, talk to engineering. Let me let you sort of go and do the next step. But this phase one is so key. This is sort of what Wiz showed you how to do already. Okay, you can do this with the open source repo. You can do this today. You do this tomorrow at work, at the bank. Okay. Now, this is cool because it's super low cost and it demonstrates huge value, and you only need to sign off from one person. Now, then you need to start going through the process. Well, now you need to refine this thing. You need to start talking to the engineering team. You need to start saying, yo, I built this app. I know I'm just a lowly data scientist, and AI engineer, whatever, and you guys don't respect me yet. But let me tell you a little bit about what I'm seeing on the back end on Langsmith, right? And like, I think P99 latency, I think blah, 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 but I don't know a lot. Can you teach me, right? Then like, oh, sure, come on in, guy. And you know what you could say? You could say, hey, by the way, do you have a prompt library? Do you have a basic RAG prompt that I can use for my RAG applications? Do you have tools? Do you have an MCP server, by the way? Do you have one yet? Because I'll build one for you. We'll teach you how to build that one later. And what can I leverage for my application that I built on my prem out of the box that you guys already built? And typically what you'll hear is oh shit, I don't, we didn't build any of that yet. Oh, well, I'll build it for you. How about that? I'll start contributing to the engineering team today. Now you're in at the first engineering team, okay? Beautiful. All right, so now, you know, you're 1 week in, you're feeling good, but buckle up because it's gonna take maybe 5 years to go the rest of the way. And this is when you'll probably start to get frustrated because it starts to get really, really hard after this. Now, at a particularly large organization, you have to play the cross-functional, everybody get on board game. Okay, well, you gotta talk to product developers, you gotta talk to the data squad, you gotta talk to the SMEs, you gotta talk to everybody, you gotta talk to security, you gotta be like, oh my God, I thought just showing my app to the engineers was enough. Of course, it's never enough. Your boss has gotta help you here. You're starting to elevate. You're starting to get visibility throughout the organization. You're starting to be a leader in the org, right? And all from this little app that you built that was done in 3 hours. But this part literally takes forever because you don't get to decide what other people think of you. And this is the part where you got to decide, do I want to stay at this company for the next 2 years? Because AI is going. And can I make 250 somewhere else? And can I just build POCs and get after it somewhere else? Seriously, this is a huge problem. Most of the people that take our boot camp, they actually end up leaving their job within 6 months or a year. It's not a surprise because you're high value. You want to ship and share. Like a legend, you don't want to get stuck up and gunked up. But if you're all in on your company and you start doing this POC thing today, you will be a leader tomorrow. And that's something that's highly, highly valuable and that every single company needs today. Of course, security has to be the final stamp. And then, it's not done once you get buy-in from everybody. Now you actually have to, now you have kind of like this terrible UI but scalable application that exists in your CSP somehow. Somehow you've done it. And it's really, really awful, but it works, and theoretically, it could scale to like millions of users. So you start testing it with people, and you start seeing, okay, does it work fast enough? Is it answering the right questions? You start iterating on this product, and you start to actually do some product development, which is fantastic. So it's functional, it's in the cloud, but it's still quite ugly, and the final phase is typically, well, at this company, anyways. If one of your core values is we make beautiful things, obviously this comes in earlier. But at this particular company, now we start to work with the designers. Now we start to work with, actually, can we scale this out? Now we have a go-to-market strategy if it's with external users. Now we actually try to roll this out to every internal stakeholder. Now we try to demand that every internal stakeholder use this, not just give them the opportunity to use it. I was talking to somebody this week, and they said, $120 million, how much is it going to save? And I thought, that sounds cool on the front end, but what are you doing a year from now to make sure that you saved $120 million? I said, how many people are using it today? Like today. And it's like 60. Okay, so 60 times 365, 120 million divided by that. Are you sure that you're going to save $120 million? How many users do you need to actually save that $120 million that you projected, right? And I think ultimately, and I was talking to this person, and it turned out, that project had started 2 years before agency even existed. And so this product development cycle you find in these large organizations is just atrociously slow in general, always has been. And I think AI, that's the one thing that people are, again, it forces you to look at your data, forces you to look at the speed of velocity in your development, in your organization, and this is just one example. Now, heading over to the bank for a second. No, if you want to talk about the bank, we can talk about the bank, but it's going to have to be one-on-one. The TLDR on that, because I want to give you guys some time to build. The TLDR on what the bank said is the bank said, well, we've always done things on-prem, and we have a strategy for over the next 12 months, we can do stuff in the cloud. And we're really, really excited for that. But today, what we need is, we know we can't hire our way out of this. We're in part of the country that, we just don't have a huge tech talent pool. So we have to train our way out of this. But at the same time, I can't really allocate budget for training, so I'm kind of stuck, just kind of looking at JP Morgan and Wells Fargo and these other banks and saying, are they so far ahead that this is actually not okay anymore? And I keep looking at them, and the reality is they're not that much further ahead that I have to solve this today. Everybody's kind of playing the same game. Everybody's kind of going slower than they want to admit. Everybody's jumping on the hype train and kind of providing the marketing hype out front. And that was the same person I talked to a year ago, and they said, well, we're just going to kind of wait 9 months. Because the data science team, and still the data science team still works in Jupyter notebooks. They don't really understand the end-to-end. They don't really know the app development. They certainly don't know the ops. Most people don't know the infrastructure. And it's just kind of a really highly tangled mess. And even us thinking about working with this bank is like, is this really a relationship I want to enter into for the next 5 years with this bank? I don't know that it is. I typically would want to work more with organizations that have a higher development velocity so that we can have an internally higher development velocity. in the things that we are providing to real enterprise customers. So with that in mind, let's go ahead and just do a quick wrap on this section of the workshop today. There is a best practice stack to build your on-prem POC. All of the political stuff that comes after is way harder in the grand scheme of things. But the technical stuff, yes, there's a lot there, but it's algorithmically set, and there's very little uncertainty today in what you should be doing, other than with your data. That's why retrieval, Empire State Building is the R, A and G are the people walking on the street. It's all about IR. This is not a new problem. Once you get this thing going, you should start using it, get other people to start using it, get that P99, get that whatever it is you think that you can get started having a conversation with engineering about. And ultimately, it comes down to maximizing development velocity. If you're working in the cloud, sure, use the cloud. Unless you can really accelerate this with an on-prem laptop, or you actually have an on-prem setup that you're using today that you have access to, highly, highly rare. This is not something we commonly hear about. And it's going to be a combination. You're not going to wait for on-prem. You're not going to wait for cloud. You're probably going to do some combination of both. So what we're going to do for the next 20 minutes is we're going to do a build session. So we got folks around if you want to build. We have kind of the cloud version and the on-prem version in these two repos. You can find them all in bit.ly/TMLS code 2025. So if you're a builder, you want to get after it this week, you want to start doing this today, you're the kind of person we want in our community for sure. And we would love to help you out. Again, we've got Jacob, we've got The Wiz, we've got Laura, we've got John here in our community, and we're all ready to help you out actually on your laptop, building, shipping, and sharing. So we'll be back after a 20-minute and then a quick 10-minute break to get into our second session of the day, which is like, what really is an agent? What does the industry tell us about this? How do we build with them? We'll get a little bit more into LangGraph that we saw here, and then, of course, we'll follow it up with MCP. So let's go ahead and break. We are back, and this is the good stuff, everybody. Because this is what everybody's talking about, and we are done with the boring business values stuff and that part of the session today. We're going to talk about hype. But we're actually going to try to cut through the noise and try to tell you what really matters when it comes to thinking about agents. So what I want you guys to sort of walk away from this part of the session with is kind of an understanding of what the heck is an agent. And also understand kind of how it's not exactly fully articulated even by the most expert people that exist in the field today, researchers and industry practitioners alike. I want to explore the categories of agents today, and I want to explore the underlying code, the underlying concepts for the simple agent that would allow us to extend a RAG application. Like a great example is, we got a question coming up after the break, was like, well, what if I have a database of data that's unstructured and database that's structured? And what happens in that case is you kind of have two different things that you might want to pick from instead of just going to the RAG pipeline. And when you have more than one thing and you have to pick, you have to sort of reason your way through which one to pick. And that's a great example of a place to put an LLM. If it's reasoning through which one to pick, we call it an agent. Okay, so all of a sudden, boom, you're in agent land, kind of doing a more enhanced, complex RAG application. We might call that agentic RAG. So we're going to sort of dispense with some of the noise today. Hopefully you can walk away with some useful things, because most people today are feeling a little bit like they don't know what is happening with agents. So there was a recent thing that kind of was like OpenAI versus LangGraph. It's kind of fun. We'll kind of get into a little bit of that. I also want to walk through how agent frameworks define agent if we look across all of them, which is really fun to do. But first, let's give you a little introduction to agents. And the TLDR on this is we have a definition. This definition is based and rooted in our values of practical AI education and building, shipping, and sharing. An agent is a system that can leverage or emulate reasoning to make dynamic decisions in an application flow. That's what it is today. If you want to make money for yourself, for your family, for your community, for your company, for the world. There's lots of other ways if you just want to be intellectually curious to describe agents, and it's kind of fun to do that, so we'll do some of that today too. So let's get away from this for a little while before we come back to it and break down agents from first principles. Okay, this should be fun. How many people have seen this textbook before? You seen this thing before? Yeah. The OG textbook, let's say, on AI. They actually define AI in the OG textbook as the study and design of rational agents. Now this is really fun. We can fall down the rabbit hole here for a second. Because what rational means is it means based on or in accordance with reason or logic. And what reason means is the action of thinking about something in a logical way. That's kind of interesting. So we're sort of self-replicating here with the logic idea already. Now, agents are a pattern, really. They're not a specific thing. I talked about the two databases, and it has to reason which action to take. They are the reasoning action pattern at their very, very core. You see, when you ask a question, you go to the agent, or this is the LLM that decides when a human used to decide which action to take. That action, of course, the second part of the reasoning and action loop, could be a number of different things before we get to a final answer. The number of different things it could be a RAG pipeline, it could be an API call to archive, it could be a Google search, or a slightly enhanced Google search like Tatavali or something like that. And so what happens is, after you hit that tool, you'll get some output, you'll get some outcome, you'll get something to observe. That observation, that new data, is going to be fed back in to the conversation thread. You might call this agent memory in some sense too. When you're having a conversation with somebody and they just go completely off in another direction, they had nothing of what you just talked about for 30 minutes in context. Maddening. We don't like it with humans. We don't like it with AI either. And what's really interesting is that kind of this paper from 2022, the React paper, kind of describes still very much where we should be thinking about agents today. Reasoning traces. Traces are the things we must then monitor and log on the back end when we build agents. How did they come up with decisions? How did they make plans? How did they actually execute those plans? Which tools did they pick up? Were they the right tools? Are those prompts optimized? These types of questions. And the actions, of course, could be any sorts of actions to gather additional information from external sources. Did anybody see the Google DeepMind talk yesterday? That was pretty dope too. Anybody see that? No? Nobody saw that? Okay. 2 people. Okay, maybe it's a different thing. The workshop and the conference, but I won't go there then, since it was just you guys. But these external sources or environments can kind of be just an API call, but they could be also an entire virtual simulated world, like back in classic RL a little bit. We can also just kind of think about these tools as kind of fancy RAG. And this is a really, really practical way to think about agents. Again, as goes retrieval, so goes generation. As goes retrieval and search, because retrieval is often, we're talking about internal documents. We're not talking about the external stuff on the internet that might be updated today. Somebody's X post, software 3.0, or something like this. And RAG is again, it's giving the LLM access to new knowledge. Now, could you hit an API call and get on Google and get new knowledge? Yeah, probably. So is an agent kind of doing prompt augmentation and kind of doing search and retrieval? It's like the simplest agents most certainly are, yes. So these architectures that take actions with tools, they get observations. These agents are the things, look at in this diagram, we just call it an LLM. This is a misnomer. Often people call agents LLMs, people call LLM agents. Are they the same thing? Are they different? I'll leave that to you guys to decide. There's some serious ambiguity there. But certainly an LLM doing the right thing, reasoning and taking action is, in fact, yes, an agent. But an agent, we might just think, is just giving the LLM access to tools. This is kind of what the agent orchestration frameworks say. LangGraph is all about tools. solving problems. Crew AI is all about tools, accomplishing tasks. You start to look into these agent frameworks, you start to see a pattern. The pattern that starts to emerge is accomplishing stuff based on the user query. This is true if you look in the OG AI textbook. This is true if you look in the new G AI textbook. This is from Chip Wen. In an AI agent, AI is the brain that processes the task, plans a sequence of actions to achieve this task, and determines whether the task has been accomplished. That sounds a lot like React. So remember, it's a study and design of rational agents. Let's pick up that thread. What happens deeper in that text? Well, the agent is defined in this text as anything, literally anything. That's how it's defined. That can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Gah, what kind of like, is that clear to all of you guys? Like, I think it was clear to Stuart and maybe his PhD students and maybe the folks that built AI in the first place, but probably not many of us practitioners today. An agent, from Chip's book, is characterized by the environment it operates and the set of actions it can perform. Oh my, that face is perfect right there. That's how I'm feeling about this too, my man. Basically, it's React, right? But we go further today because there's all sorts of things that people are calling agents. It's like, well, are these all kind of the same thing? You know, this is the computer using agent. That means it's from OpenAI, not Anthropic. Perception, reasoning, action. Okay, I think we sort of have this little sandbox. This one is the clicky, typey agent. This one can do that. And it sort of came from this idea of, and this is so interesting too, is like these OS world type of benchmarks, right? These sort of competitive programming type of benchmarks. The people who are the best at these things are the people who founded companies like Devon, like Manus. These are the people who are building the autonomous software engineer applications of the future, like the computer use agent, like the computer using agent. And what's interesting too is that you'll hear things from Anthropic, who came out with this in the first place. It really didn't take all that much to sort of say, hey, take the mouse, hey, take the keyboard, it's your new environment. And so how can we think about that? Well, we can kind of go back to our other loop, and those are just tools in our little toolkit. The reasoning brain, the big brain on top is like the thing. It's not the tools, although the tools kind of are the thing. And so when we can do all these different things, we can kind of do a whole lot pretty easily with this agentic reasoning loop. Now, there's a key insight here, which you'll see down here. It says, one fine-tuned LLM call per tool or function call. So what actually has to happen here, and this is super interesting, is that we have to have a reasoning step, and then we have to have a tool or function call step. And this reasoning and action step here, it basically is compressed into what we call function calling. Okay, so in short, function calling or tool calling is reasoning and action in one step. It's been fully compressed because we give a prompt and it just calls the tool. Magic. But it's not really magic because it's just a fine-tuned LLM. Again, we're not going to talk about fine-tuning and training LLMs, but because it's table stakes today. You're supposed to already know about it. Again, we've got that open source content. You can check it out. We can also think about workflow complexity with agents. I like to think about complexity because I like to nerd out on stuff that Stephen Wolfram says and have for a long time. It's well studied that very, very simple rules taken together, agglomerated over time, can produce very, very complex results. At least complicated results. Complexity is sort of this thing that I think we often don't draw this line quite enough, complexity versus complicated. Agents are not a new idea, as we saw in the AI textbook from a very long time ago. This is a book from also quite a long time ago, studying kind of the lab, the research lab of a bunch of legends that came together to study complexity. And there's still some research labs out there doing stuff like this. Of course, the AI labs are going faster than they are today. Agents can kind of be anything. Again, that was the text definition. They can be people in the city, they can be consumers and corporations in an economy, they can be neurons in the brain, they can be sort of anything that at the next level allows us to get something that emerges. And that's just not, it's like cool intellectually, it really is. It's kind of cool, especially as we think about simulations. We think about the Google DeepMind thing yesterday, that was super hype. We can prompt to video game we can play. You know, and then our agent is driving this entire generation of this environment and the instantiation of that agent therein. But when we talk about building in practice, we really shouldn't be overly complicating or overly complexifying anything. Although if we got to get on the hype train and do an MCP server, you know, you got to do what you got to do. We understand that. But again, business value ROI doesn't care about that. And so the question about agents is, when do we really need that complexity? When do we really need it? And the answer is when we need the reasoning and decision making and flexibility in determining the workflow. We can have a simple workflow that's clear and consistent every time, or we can have a workflow where you're going to basically be able to go over here, go over there, go over there. And do you need that, right? You have to ask yourself that question for your application. Is it really just keyword search that you need? Is it really just fuzzy match keyword search that you need? Do you really need to return all this context? Do you really need to do this to generate the right answer and to help that human solve the real problem, to help that customer solve the real problem? And I think, you know, one of the slightly dystopian ways that we could view the future is we could imagine ourselves in front of our screen, and I think, who was talking about this? Somebody at the bank yesterday, I heard us talk about this. This was really great, because he said, well, we have to think about human fatigue as well on being slammed with things to verify and validate. So we actually want the agent to be fully autonomous and validate some stuff so we don't fatigue the human too much. So the agents are quite thoughtful these days with us in mind. If we think about a future where we work at, let's say, the bank, and we're sitting in front of our terminal, and all we're getting is, it's not an agent chatbot, although we might have chatbot interfaces. It's an enterprise workflow that's like the brain above all of the brains. That's sort of deciding, okay, this customer complaint, I heard this, I need to go over here, but I need to find this data. But I don't have access to that data. So human, can you give me access to that data so that I can get this data to come back over here and solve this problem for this? And so you're basically like, it's like human, please validate this, please validate this, please validate this. And so you turn into sort of the software equivalent of the manufacturing line, so to speak, right? That's what you turn into. Hey, this is where we're headed. So how are you going to get out of this? Well, you can be the person that builds the workflow, maintains the workflow, and improves the workflow. And, you know, I think it's not clear where we always need super flexible workflows. And again, just as the AI transformation points out where your data kind of sucked, it's going to point out where your workflow kind of sucks. And you should just improve that without AI. Okay, let's back up again. So we have the study and design of rational agents. We have rational meaning based on according with reason. So when we're talking about agents, what we're really talking about is we're talking about agentic reasoning. Now, there's this idea, we had a reporter interview us this week, and they were like, well, our readers were like, well, you know, one of the questions we get all the time, one of the most Googled questions, right, was agentic AI versus agents, right? And it's just like, oh my God, can we stop this? You know, it's like, no, we can't stop this madness. Okay, there's no difference, okay? But it does depend on how you define agents. So maybe there is a difference if you want to contrive a difference. Do you want to contrive a difference for your org? Will it help you move forward and generate more business value? Maybe it's useful. For us, it's not particularly useful because we teach people how to build, ship, and share applications like Legends. So we'll get back to our definition soon. We can kind of think about agents in a couple of different ways, though, already from this. Giving the LM access to tools, giving the LM access to new knowledge, sort of enhanced fancy RAG, and fundamentally the reasoning action pattern itself. This also gives way to this idea of, well, what about multiple agents? When do I need multiple agents? And if we think about kind of the idea that we have to ask ourselves, when do we need complexity? When do we need an agent? Well, go back to the two database problem. I need to decide if this, then that database. If that, then this database. That's what I have to decide. And so when you get enough if-thens that you have to do reasoning and you don't want to have to do it as a human, you should use an agent. When you get enough if-thens that the agent has to deal with, what happens if I have 86 if-thens and databases to choose from? You're like, well, I mean, that seems like a heavy number of if-thens, and it's going to kind of make mistakes. And you can run this experiment. Does it make mistakes often? Well, it probably makes more mistakes than with two databases. Is that too many if-thens for a single agent? Maybe I should add another agent. This is when we get into multi-agent systems. And of course, there are very, very famous multi-agent systems that we hear about, the most famous today being deep research, all the things that basically help you write reports and search the internet. And I love the reasoning models. They're so, so good. They're my new default. I love watching the reasoning traces. I love looking at how many web pages get searched from a single query. These are multi-agent systems. ChatGPT is a multi-agent system. Claude is a multi-agent system. These are all multi-agent systems today. And one way to think about reasoning that's really cool is you have just a bunch of agents and you let them talk to each other. They generate a conversation thread and they reason through things together. You might also call this enhancing test time compute, if you want to be really fancy about it, right? Reasoning can happen in so many different ways. It's the pattern of reasoning that matters. You get a bunch of SLMs in a room, you let them chat, there's going to be a conversation thread. You get a single LLM working through many different loops of the cycle, you have a conversation thread. You basically have two databases, you have a reasoning thing you have to do there. So it's not about, is it an agent? It's like, do you need this reasoning capability? What's the way to inject this into your application? What's the way to enhance the human experience? We define agent as a system that can leverage or emulate reasoning to make dynamic decisions in an application flow. This extends well to multi-agent applications because we can say a multi-agent system is a system that can leverage reasoning from multiple independent agents. Oh man, we use agent in the agent definition. But I hope you'll allow it, based on the context we provided here, to make dynamic decisions in an application flow. Okay, this is important because this is ostensibly what all of you guys need to be worried about. Because we can define this in lots of ways, like the Turing Institute. This is just not a useful way to define it. Sure, if I'm doing research into reinforcement learning, it might be interesting to think about this. If I'm working on this, the SEMA team or the Genie 3 team at DeepMind, it might be an interesting way to define this. But if I'm working in a business that has to make money and my job is to make more of it, this is probably not a useful way to define this. So one question is, yeah?
So I don't want to go too far down the rabbit hole, but if you focus on the word system on the previous slide,
Yeah.
the system could involve traditional applications, traditional database systems, because an agent might, or the MCP we use, they have to, in the real world actually, they have to talk to existing legacy stuff, right? So when you say system, it's not only composed of agents, most of it could be traditional apps and traditional databases, right?
It depends who you talk to when you say most of, right? And it's like, I hard agree with you, and the intellectually curious part of me is like, absolutely right, 100%. We can go up a level and we get more meta, and we can talk about solving the problem and more generally, but the particularization of the general use of these models and the general development of like reasoning models and all of this stuff is the way that we create, and capture, importantly, value for, ourselves, our companies, our communities, and the world. But there's lots of ways to measure value, right? And one of those is just like, it's really fun and cool to like nerd out on meta problems, which is the role of the researcher and the university professor. And I enjoyed my time at university quite a bit, but one of the things is that it was never quite practical enough in many of the discussions that I had with other professors. And so why would I need more than one agent? okay? Well, you need more than one agent when you need to reason through more specific things. If you think about the idea of if we solved AGI, would I need more than one agent? You know, it's like if I got the AGI, then it's kind of a multi-agent system already for sure, and it's like again, these are intellectual curiosities. These aren't brass tacks business issues. So we want to think about reasons we might use multi-agent systems. Separate out prompts, separate out types of databases, access to specific types of tools. You know, you have different roles. Think about job descriptions for your agent, or you want to fine-tune specific things that the agent or one sub-agent might do. So if the task is complex, we can sort of set up a system to match that complexity. We want to use agents to not make things more complex, but to make things simpler. And, you know, again, very simple rules can add up. With, you know, enough of these simple rules, we can get emergent complexity. And so with enough agents, with enough simple rules, with enough interactions, we imagine, you know, the banks of the future in 10 years from now, they're going to have some serious emergent complexity. This is kind of the promise of AI in general. And I think this is where we all are sort of excited and optimistic about the future. Some of us are more optimistic than others, of course. There are lots of different levels of agency as well. And this is one of the things that's important to sort of think about. This is a bit far down the rabbit hole. And, you know, basically we are at this sort of IDE coding agent level, all of us using Cursor. Or if we use the Manus, the Devon, the autonomous suite of today, we're at the web coding agent. We expect sort of higher levels more and more with time. And we can kind of ask, like, how far away are we from the actual work being done or that used to be done? How far away are we from the scoping, from the planning, from the reasoning, from the coding? Maybe the coding, that's more the engineer side. Maybe the scoping and the planning and the reasoning, that's more on the product side. It's coming for everybody. At what layer are you supposed to be working today? So what we want to do is to kind of talk a little bit about what some of the folks that lead the industry are saying. This is from Harrison Chase, the CEO of Loughnane. OpenAI, so misguided, really. Declarative versus non-declarative, that's an insane thing to say, OpenAI. People are arguing pedantically about agents, and it's really, really fun to look at. You'll have access to these slides, and you can kind of go a little bit deeper into some of the pedantic back and forths, and we've got some events on this as well. This practical guide to agents that OpenAI released kind of sets you up to build your first agent. And this idea of what is an agent, when should you build an agent, and all of that is more discussed in an event we did recently. Harrison kind of put out, here's what I think about agents, because it's a really interesting question. And one of the TLDRs on this is a thing that we should all not be surprised to see. Making sure the LLM has appropriate context. That's the role of the agent. It's like, oh my God, is that it? You know, it's like, yeah, we kind of know, right, about AI engineering already. We kind of know about the stack that we're using already. We kind of know that we need to get stuff in context. Actually, where's agents again? Oh, agents are right there. That's where they are in this stack. Agents are just hitting API calls and hitting tools and hitting, I guess we should put MCP servers on there. There's another TLDR that's worth thinking about for all of you guys as well. And this is agentic systems consist of both workflows and agents. So this is something that came out of this whole rigmarole that's kind of interesting. So Wiz, I'd love your opinion on this. We have workflows and we have agents here. It looks like workflow means no agency, but yet it's still on the agency axis. And it looks like agency means no workflow, but yet it's still somewhere on the workflow axis. Should we be building agents or workflows?
You should definitely be building LLM-powered applications. You know, you can call them whatever makes you feel happy, whatever your leadership wants you to call them. At the end of the day, the distinction between workflows and agents is a very personal distinction. There is no authoritative body that's going to come down and say this is X or Y. It is, at the end of the day, you're building a system that is in some way autonomous or in some way has autonomy, and that's really the thing you need to think about, right? Workflows are a good mental framework to think about constructing these systems, and a good way to give guardrails to an autonomous system that has the ability to act in the world, right? But you know, even in the most unrestricted version of an agent, it still has some kind of guardrail. There is some interaction with an application. There's a while loop or whatever structure you're using underneath, and it's still in some way limited or in some way on rails. You just can't get away from that. So this can be an interesting way to talk about it if everyone in your organization agrees on the definitions of these two words, and if you've had those conversations. If not, it's up to you guys to define what they mean for you and your applications, the same way that every other person in the space is trying to define what these two words mean, and their specific and exact distinctions.
Oh my God, did you just say workflows are guardrails?
Not in so many words,
Yeah,
but
yeah.
they certainly are more.
It's almost
on
like you're
rails.
mixing words out here. That's part of the challenge, isn't it? Is sifting through all of these words that kind of overlap and mean
Yeah, and
similar
I think
things.
none of these words really help you build a better application, right? And being locked in kind of the language definition space means you're not building something that does something. And for as much as we want people out there quibbling about exact wording and we want people to be concerned with this, certainly when we're building an application that's supposed to fill some need, you can call it a truck, it doesn't matter. As long as it does the work it needs to do, that's ultimately what we should be as AI engineers and builders concerned with.
Okay. So in short, should I use workflows or agents?
Absolutely.
Yes. Okay. All right. Thank you, Wiz. All right. So what I want to do is I want to sort of look at this question of what is an agent across agentic frameworks and their code bases. If you look in their docs, like what do you see? And this is sort of inspired by the post that Harrison made about like calling out OpenAI. And what he did is he said, well, we have all these frameworks, and the frameworks are right here. LangGraph, Agents SDK, Google ADK, LangChain. We've covered basically all of these on our YouTube channel. You can check out the details of each one, but the core foundational concepts are the same. And check it out, they're the only ones that are declarative and imperative, hence his initial call out. But the idea is like these are quickly reaching feature parity. Do you have a quick question?
What's human in the loop versus human on the loop?
That's a great question. You're going to have to dig into Harrison's thing for that a little bit more. Do you have a human in the loop versus human on the loop tidbit, Wiz?
You have to read Harrison's blog. He gets really deep in the weeds and some of this stuff, yes.
Yeah. Okay, so what we want to do, though, is we want to take just a quick high-level view of like what those frameworks tell us an agent is, and this is quite interesting. So LangChain says it's a system that uses LLMs as reasoning engines to determine which actions to take and inputs are necessary to perform the action. After executing the action, blah, 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 blah. This is often via tool calling. Okay, that's a mouthful. Next. OpenAI Agents SDK. Agents are the core building blocks in your apps. Thanks, OpenAI. An agent is an LLM. Huh, there it is. Configured with instructions and tools. There we go, we got the tools. You go to something like AG2, they don't even mess with trying to define agent. They just say, no. We have a thing and you should use it. It's the core construct, conversable agent, okay? And look at this, communicate with other agents, process information using LLMs, make decisions, reasoning, execute tools and functions. Tools. What about Crew AI? Crew AI says, an agent is an autonomous unit that can perform specific tasks. It can make decisions. It can use tools. It can communicate and collaborate. It can maintain memory. It's got a conversation thread. It can delegate tasks. Okay, kind of like, I feel like I'm dancing around this idea of agent here. Small agents, oh, so good. Small definition. Program where LLM outputs control the workflow. Llama Index, what do they say? They say it's a semi-autonomous, not an autonomous, this one's semi-autonomous now. Piece of software, oh, even more meta, powered by an LLM, given a task and executes a series of steps until it solves that task. Okay, let's just get a little bit out there here with DISP. The framework for programming rather than prompting, language models. And it allows you to iterate fast on building modular AI systems and offers algorithms for optimizing their prompts and weights, whether you're building simple classifiers, sophisticated RAG pipelines, or you're supposed to know the definition already, agent loops. We can go further with things like pedantic AI. I was hoping they'd be a little bit more pedantic about this AI definition, but the primary interface for interacting with LLMs. But I do like this. They did get kind of pedantic here. Conceptually, you can think of an agent as a container for system prompts, function loops, structured output types, dependency. And try to explain that to your boss, okay? Try to explain that. So, I think when we look across these things, we see some similarities. We see some things that are not so similar. But ultimately, we can see the same pattern. It's agentic reasoning. It's the reasoning and action pattern. It's fancy RAG, it's accomplish this thing, it's do this task, it's use this tool, you make it more slightly simple by leveraging the right amount of complexity. It's use workflows and agents. It's give the thing agency if it needs it. If I run out of if-thens, use an agent. If I run out of if-thens again, use another agent. And so, there are some things, but I think, the point we're making with this particular one is all applications are going to need both, and you have to define what these words mean for your organization. So let's build one of these things. Let's build one of these things with LangGraph. And let's think about how we can increase the complexity stepwise. We can have a simple API call, lame, right? Super lame. And this is just kind of on the back end, how to use ChatGPT as a developer. It's like system user assistant or developer user assistant prompting level stuff. We can do a simple RAG application. Oh, we just did that. We actually did it with LangGraph already. And it looks just like this. But that's kind of also pretty lame. We can start adding a little looping, a little if-thenning, a little agentic reasoning, and we can sort of allow ourselves to decide which tool we might use in a loop. And so when we ask a question, we can actually go quickly and decide what are we going to do. So we're going to use LangGraph for this. We already showed you a little bit of LangGraph, but we didn't really talk about it at all, and we're not really going to talk about it that much here either. But we do talk about it quite a bit on YouTube and in our courses. The thing about LangGraph that you should understand is that when we sort of built out the RAG application here, what we're doing is we're actually doing a graph. This is called a DAG. It is not cyclic. It is acyclic. It is a directed acyclic graph. What we want to do with LangGraph is, yeah, sure, we can build this, but it seems a bit overkill because we don't even really need to put cycles in it. Of course, when we want to leverage the pattern of agents, when we want to add complexity to the workflow, we want to move from DAGs into directed cyclic graphs, decags, something like this. And to use a graph is quite simple in LangGraph. To use a graph is really powerful, and this is for all the product people out there. If you can draw it on the board, your engineers can build it in LangGraph exactly the same way. This is not true in event-driven architectures. This is not true everywhere. Typically, this is part of the pain, the PITA problem, but this is not actually that big of a problem when it comes to LangGraph. And so we're going to use a collection of nodes and edges. The nodes are going to be things like function calls. The edges are going to be things like where do I go next, or reasoning paths. And so what we do is we build a graph. He sort of showed you this already. We set it up. We add nodes. We add edges. We close the loop. And that allows us to sort of use our library. What we'll do is we'll show you today a build with this data. Oh wait, no. We're not going to use any data because this is an agent. Wait, is that right? I don't know. But it is if we don't have a RAG pipeline in our agent system, because we don't need an embedding model. We can just ask a question, and we can, in fact, these are hot takes you'll see on LinkedIn this week. Stupid RAG, you don't need it, build an app without it, because you can ask a question, and you can just go hit an API. Who needs RAG? It's dumb. And you can get an answer. Now, what's interesting is this is all within a single node, if we'd like. And so you could put an entire single agent in a node. You could put an entire multi-agent system in a node. You could put an entire RAG. You can do whatever you want because it's sort of a very meta thing to build these nodes. If you're interested in the details of this stuff, we have lots of things for you to check out and go into. But what we want to do today is we want to sort of build out something that kind of puts a lot of these pieces together. I want to build out a simple system where we have a supervisor and we want to delegate some tasks. And the interesting thing to think about is that when we're delegating tasks and we say, hey, I'm thinking through which task do I need to delegate, boom, I'm going to delegate this task. It's the same process as that of tool calling or function calling. So the multi-agent system is just sort of this router on top of different agents. Since the router is just a function calling tool, supervisors, we might just say they're kind of just function callers. But they do reasoning, that's important, and they get paid big bucks for that. But it's hard to get paid for strategy, man, always has been. And so one of the ways that we can kind of simply think about multi-agent systems, as you'll see, is they're kind of just function calling all the way down. We can set them up in different ways. This is one where we can actually put in a paper and we can say, generate me a pretty dope LinkedIn post, and then we can post it because we like to build, ship, and share, not just build and ship in silence. So that's what we'll do. We'll sort of input an archive paper and we'll sort of say, write me a post. This is any old paper will do, and I encourage you guys to do this actually yourselves, and make sure that you can kind of pick your favorite paper from today and share something as a result of this workshop. And the way that this is going to work is, and Wiz will go through this a little bit quickly, but it should be fun to watch. He's going to build a research team, and then he's going to build the supervisor, and he's also going to build a document team. And there's going to be like a whole bunch of agents set up like this, so that we ask the boss for the input and we get the output. And at least this is kind of the way you can think about deep research working a little bit. It's towards that. But it's handcrafted and it's from scratch. And you should also try, of course, because this is about practicality, putting in that same paper to deep research and saying, generate me a dope LinkedIn post, and see if this application was even useful at all in the first place. But it'll work for a toy problem today. And with that, I want to go ahead and hand it off to the Wiz to show us how every component of a chain is a runnable, every node in a graph is a runnable, and every node in a graph can also be another graph. It gets pretty meta when we build super complex systems. That's why we should keep the complexity low. Wiz.
Alrighty, we're gonna blitz through the second notebook of the day. This one is available as a collab notebook. If you want to use that, I'll just go ahead and zoom in. Good in the back. You can see it. Nice, perfect. Okay, so at the end of the day, this is kind of where you can wind up with LangGraph. So there is another notebook in the repository that is kind of like the intro to this notebook that will lay some of the foundation or groundwork for you if you're not quite sure what I'm about to talk about. But the idea is, and we'll zoom out just for a moment so we can see the picture. We're going to build this structure. You can't really see the lines because the screen is, got light on it. But the idea is that we have some supervisor agent. It supervises some team, which is that team is itself a supervisor agent. And then that team has access to team members, which are, you guessed it, agents, right? So it's agents all the way down. It's one agent calling another agent calling another agent. That's the pattern we're looking at. This is a hierarchical agent structure. Big fancy word just means that there is a hierarchy to our agents. One agent reports to another. This is a useful structure because it helps us keep function isolated. Now, there's a number of applications for which we don't want to look at actual, factual, multi-agent systems. There's a number of blogs that have come out recently that have expressed this, right? Multi-agent for code is not yet chillin', but the idea is that we are going to look at this hierarchy to do something that isn't coding, which is writing a document. Okay, if you're using this in Colab, you'll need to uncomment these lines. You need to run them in order to get your requirements. If you're running this locally, this will be handled through UV. Just make sure that before you run the notebook, you go to your terminal and you're going to run UV sync, and that's going to ensure that you have the correct environment set up for this. We are going to be using OpenAI as our LLM today. So before we got away with Llama, 3.3 70B instruct, which is a great model, but it's not the smartest model in the world, right? OpenAI has produced a number of very good models that are well suited to this kind of task, right? We're actually going to use a couple different LLMs as we move through this because each LLM has different burdens of responsibility, right? We're also going to use a Tvili API key. Tvili is it's like Google, but wrapped in Python. We're going to start with RAG, what we just already did, right? And then we're going to shove that as a tool in our flow. So same thing as before, except we're going to use a pre-built loader to load a PDF. We're going to use a recursive character text splitter. The reason we are getting away with this is because PDF text is in a very well understood format, which is paragraphs with headings. Recursive character text splitter is going to make sure we're keeping together chunks as good as possible. If you're using like Wikipedia text or PDFs that are formatted in a traditional format, recursive character text splitter is just fine. It's not the most optimal. You can spend more time to get even more optimal, but we're just worried about chunking this stuff. We're going to wind up with a total of 15 chunks. We're going to shove those into a vector store. We're still going to use Quadrant because Quadrant's great. We're going to use OpenAI's embedding model, which is text embedding 3 small. It is a great closed source embedding model. It's cheap, it's fast. We love all those words. Once again, we're going to use a RAG prompt. And then, of course, we're going to have a generator. For our RAG pipeline, we're going to use GPT-4o Mini, right? We don't need a big, beefy, big-brained model to do RAG, so we can get away with Mini just fine. You can even use Nano here if you really wanted to. We really don't care about the performance of the generator in RAG. Almost all of the time, every unit effort you put into the system is going to get better returns if you put that unit effort into the retrieval process instead of the generator. We're going to tie this together in a RAG chain. All this is doing is it's kind of hard coding the chain, similar as what we saw before with LangGraph. We just go from the retriever to the prompt to the model to a string output. Now, one thing that's important to realize about this, though you might have questions about the syntax, I'd refer you to the previous notebook, which you can work through after the workshop. This thing that we wind up with is called an LCEL runnable. You don't have to know what that means. All that matters is that it's a special object to LangChain and LangGraph. And the runnable is kind of this standardized interface or protocol that we want to use and it is what allows us to glue different pieces together very easily. So each of the things that are wrapped around the pipes are also LCEL runnables, and we compose them together into an LCEL runnable. You can kind of see where this is going, right? These are the Lego blocks of the framework, and we can just click them together because they all share the same interface. Okay, we can use our RAG chain to ask questions like what does context and long context refer to, and we get to the amount of text that a language model can process. Yes, great, that's great. So we've built our RAG tool. Again, we're hard coding this into our pipeline. This is a RAG pipeline, right? If you wanted to replace it with some kind of archive search, you could most certainly do that. But for us, we're going to have this as a stand-in for proprietary data, data that we don't have shareable, publicly accessible on the old internets. Then we have a bunch of imports. You love to see it. Thanks, Python. And then we're going to create a number of helper functions. So each of these functions is just going to be a reproducible boilerplate blob that we're going to use over and over again for the rest of the notebook. We're not going to talk too much about what's happening in them. We're just going to let you know that they exist and they do the things that they say. So the agent node helper function is going to be or act as an agent node in our graph, right? So we saw before our graph had the retrieve and then generate nodes. This node is going to wrap an entire agent. It's going to take in state and an agent, and then it's going to return some output from that agent, right? We're gonna not worry about what's happening in the agent until later when we set things up. We also have the agent creator helper function. This create agent is going to build the actual agent that we're going to use. And this is going to be the agent prompt that we're going to use for the entirety of the notebook. Work autonomously according to your specialty using the tools available to you. Do not ask for clarification. Your other team members and other teams will collaborate with you with their own specialties. You're chosen for a reason. You're one of the following team members. This is a very simple agent prompt, but the idea is we just need the LLM to know it's doing some task, and all it does is that task, and others will do other tasks, right? We want to leave space for the LLM to understand that, oh, well, there's a specialist that's going to do this other thing, so I don't got to do that, and that's what's going to facilitate eventually this communication between our different agent teams. All this other stuff is just boilerplate to make that go into the LLM. That's all that's happening there. Then we have our supervisor helper function. You're going to see this absolutely gross JSON blob. So underneath the hood, this is what we're actually passing to OpenAI and other API providers when we do things like function calling. OpenAI's API doesn't understand just a Python function. It needs a representation of it that it can leverage, and that's this JSON blob. You'll notice that this is defining what the function looks like, what properties it has, how we can call it, what is expected to be called with, and what is required to be called. So this is basically just a map or guide to our LLM that showcases how it is we need to call a specific function. Now, what does this function do? Well, very simply, it says where to go next. So our supervisor is a glorified router, right? It basically says, I have this task. I need, which team member is going to be able to do this? And that's all it does, right? This is still a very crucial component of our workflow, but the astute among you may be thinking, well, golly gee, couldn't that just be some kind of classifier? And indeed, eventually it will be some kind of classifier. But until we have enough data to make that so, we allow the LLM to do its thing. But that's all it's doing. It just says where to go next, right? And how to get there. Again, we set this all up. There you go. Finally, we have the actual stuff that's good and does the work. The first team we're going to produce is our research team. The research team is going to have access to Tavili search, which is just Google, and our RAG chain, which represents our proprietary data. For tool creation, it's pretty straightforward. We basically just need to create a tool. If the tool already exists as a tool in the LangX ecosystem, then you can just call the actual tool itself. If it doesn't exist, you can use the tool decorator to easily create a new tool. Things that matter when you're using the tool decorator, this type annotation from our very, very good friends, everyone should love them, at Pydantic, right? We need to express very verbosely what is expected from each component of our tool. So beyond just saying that query is a string, we also provide some annotation that says what string should be or look like. And this doc string is not for humans, this is for AI, right? One of the things that you're going to get used to when you're doing AI engineering is that everything you write is a prompt. The function name is a prompt, the doc string is a prompt, the type hinting is a prompt, right? All of this is context that our LLM is going to consume in order to create a situation where it's most likely to, produce a response that's in some way useful. But don't sleep on things like doc strings. They're also good for humans, okay, so you should be writing them anyway, right? But in this case, it's actually necessary for the application to work. Perhaps AI has just been a big thing to make us write well-documented code this whole time. Who knows? Okay, but our retrieve information node does one thing. It takes a query and it returns some text. Very good. We're going to start with some state. So we've already looked at LangGraph to produce our best practice RAG stack. We're going to use it again in exactly the same way. We start with some state, which contains some useful collection of things we need to care about. In this case, messages. That's all the messages that have occurred so far. Team members, that's who's on the team. And then next, this is what should be next. Now, you'll notice that we have this, this annotated list base message with operator add. What this means is that every time we get a new message from our team, we append it to state. So state just grows endlessly. The reason we do this is that we want to have all of the context so far, right? Our LLM does not have any sense of memory. If we don't tell it or show it what it has already done, it will just do stuff again, right? So if we've already asked the LLM to research a specific topic and it's already in the chat history, we don't want it to do that again, so we express to it everything that has done up to this point. So this is a very basic implementation of memory in state. Okay, next we're going to give it a brain. Just going to use 4.0 mini. Again, this particular tool is basically just RAG. Greg said something very fun, which is that all this about RAG and it's useless, and why not just have the the agent do it? We can just have the agent Google something, and then we can use the results of that Google message to augment our generator. It's just RAG again, right? So we're going to do what's called, in some spaces, agentic RAG, which is, they've put a shiny new hat on RAG, and it makes people feel very happy in marketing meetings. But to us, it's the same thing. We retrieve context, and we augment the generator with that context. There you go. Okay. That's our pre-work. Now we're finally going to create our first agent, right? We're going to have our search agent, and our search agent is going to have one tool, and that tool is going to be the Tavili tool. We're going to say that it's a research assistant who can search for up-to-date, I've opened a dictionary, who even knows, up-to-date info using the Tavili search engine, and then we're going to use this functools.partial. Don't worry about that, that's just good Python stuff. But this is it. This is our search agent. This is the first member of our first team. We're also going to create the RAG agent. We specify exactly what information this research assistant is capable of answering questions about, and we pass it the retrieve information tool, which is the tool we wrapped our RAG pipeline in. Again, all runnables. Everything that we've seen so far has been a runnable, so we can just stitch them together however we wish. Finally, we're going to create our supervisor. You'll see the supervisor's prompt is a little bit verbose. This is because we need it to do very specific things. The idea is that we let it know what tools it has access to. We tell it what it needs to do, which is to essentially work through this problem until the research teams are finished with this. And really crucially, our supervisor is also going to have access to the chat history from our worker agents, right? And so the supervisor is going to be aware of what has been done up to this point, and if anything else needs to be done beyond this point. We create the graph. The graph is created very straightforwardly, exactly the same way that we created the graph before. We just add nodes, and then we create this conditional edge. This conditional edge is part of what makes this a agent, though some may want me to call it a workflow, right? The idea is that the conditional edge is going to look for some decision that is put into state in order to do one or the other thing. So this is how we can have a branch. And what we're going to use the branch for is to introduce the potential to loop, right? So instead of just being able to go to one node or the other node or the end, or instead of just hard coding, you go to one node, then the other node, then the end. We're going to allow the LLM to quote unquote make the decision of which node to go to next and when to terminate, right? And because the LLM is deciding when to terminate, again, deciding there in scare quotes, we are therefore, we have the potential for it to loop, right? We have the potential for it to decide, I am not yet done. I need to do more iterations in order to become done. And this is the big piece, right? This is the decag, the cyclic. Okay, so we're going to look at the graph because just talking about it's a little bit abstract. But the idea is, with this mess of arrows, what you can see is that we go from the supervisor to search back to the supervisor, right? We go from supervisor to paper information retriever back to the supervisor. And then finally we can go to end, right? So we can hit search like 6 times before we go to end. We could hit, both of these nodes before going back to end. And this is all going to be determined by that supervisor agent based on the context of the chat history. So this is the idea, right? We have this dynamic decision making in our application flow. We're going to create the enter chain helper function because we need to stitch this together later on. Yes, what's up? We got a question.
Can it get stuck in an infinite loop?
So yes, if we weren't clever, it could absolutely just never exit, right? So like it could always choose to go get it. We actually have LangGraph comes out of the box with recursive depth limits. So after some number 30 by default of loops, it's just going to say, I'm good, bro. I've gone through enough. It's time to exit. And we can actually track, if we want to have the power in our hands, we can track how many cycles it's gone through by having a new object in state called cycles. And then we can add conditional logic to exit once it's reached a certain number of cycles to prevent infinite loops. So there is built in to LangGraph something that prevents the infinite loops. But we can also, of course, engineer it to exit early or exit upon some other condition as well. A great question by default. If you're using a framework, any of the frameworks really, there'll be some arbitrary limit set on how deep it can go before it needs to exit. Then we can use the thing. So using the thing looks very straightforward. We ask it, what are the main takeaways from the paper? Extending Llama 3's context at tenfold overnight. Please use search at blah, blah, blah. You get the idea. It is going to go ahead and it's going to look at the tools. It's going to use the tools to make a decision. Something that's very interesting about this, right? If we look at our graph, you'll notice that is there a reason that we would not be able to run search and paper information at the same time, right? And the answer is no. They're not dependent on each other, right? We can, in fact, run them at the same time, right? And then we can collate that information together. And LangGraph does this for us. That's one of the reasons that it's suitable to move into production with LangGraph, is that it's going to automatically do this parallelization. So if I ask a question that requires the use of both search and paper information retrieval, and it makes sense to do them at the same time, so one is not asking about the results of the other, then it will just do both at the same time, and we'll be able to save ourselves, seconds of latency. Okay, so that's our research team. Our research team, it researches. We love that. Now it's time for our document writing team. I'm going to move a little bit more quickly through this one since it's exactly the same pattern that we just saw, just with different tools, and we'll go there. You'll notice that this one has like many more tool definitions, and there are many more lines of Python code. Don't be scared. Again, a lot of this is just because we need to be very descriptive to the LLM. So a lot of this is just prompt, right? All of these annotations, the doc strings are just prompts. And basically, these are a set of tools that allows files to be written to our system, read from our system from a specific directory, and edited. The idea here is that we're giving the LLM access to produce, create, and edit files so that it can use those files to create a report that we want at the end of the day. So there's going to be a lot of code, but the code is just because we're being very verbose, right? So we have the tool of create outline, which creates a file and writes to it. We have the tool of read document, which reads a document. We have the tool of write document, which is unsurprisingly going to write a document, and editing a document, which is going to insert lines, edits to a document. You'll notice we're using this hard-coded working directory, so this is not going to, it's not going to choose root. It can't choose root. We have taken care of the working directory, though any files that exist in a subdirectory of your working directory are up for grabs, let's say, so be safe. Be safe out there. When we start with our document writing state, it's exactly the same as before, except we're also going to keep track of what files we've created. This is useful so that the LLM can leverage those files. Let's say my copywriting agent writes a specific file that might be good practices for my other files. We can read that in as context, etc., etc. We're going to go ahead and create many agents: the doc writer agent, the note-taking agent, the copy editor agent, aim special, the dopeness editor agent, and our doc writing supervisor. It does exactly, they'll do what they say. You can read the prompts with more time, but the idea is that we're going to be able to create, edit, and read files and use that as like a working scratch pad for our agent team to produce better documents. Right? This is, again, we're kind of cheating memory here, right? We want to have this persistent artifact produced by one agent that another agent on the team can look at. The same way that you might send to somebody a PRD and they might send back to you a POR, however your business works. The idea is that we're sharing documents between teams that capture our findings or our learnings, and we want to reference them when we're building whatever we're building. Finally, we create the graph. The graph looks scary because there's many lines of code, but you'll notice it's all the same line of code, just adding different nodes. We have more team members in this team, and so we need to add more nodes to the graph. That's it. And then again, we have our conditional edge, which is a map between our supervisor and the others, and we'll look at what the graph looks like. It looks like this. Exactly the same as before. There's just more team members that our supervisor can leverage, so nothing special there. And then finally, of course, we have enter our chain. And then we have, this is just a doc writer. You can see it goes from the doc writer to the note taker to the copy editor to the dopeness editor to the finish. Every team member gets to have a hand in this process. That's what we love to see. And finally, we can staple this all together with a meta super. The words always sound scary, right? But like all this means is it's just another supervisor. And it supervises, instead of individual team members, it supervises the other supervisors, just like you'd expect in a normal business, right? Your manager has a manager. There you go. Okay, same thing with agents. All it does is it's the same pattern. There is one very innocuous but very important chunk of code here, which is this. These three little objects. We need a way to interface between graphs, right? The same way in a business, you need a way to interface between engineers and management, right? You can't just let the engineers send what they're working on directly to management because they're not going to have any idea what the heck you're talking about, right? There's way too much context. You can't make a decision with that. So what we do is we only send the final response of our subgraphs up to the supervisor, and we only send a single message down to our sub teams. Again, all of this extra context is just noise to the big boss, right? They just need, what was the result? What was the end? What's the output, right? Let me make a decision with that. And so that's how we set it up. And of course, we create a graph. This is exactly the same graph we saw before. We add the nodes, easy peasy, and then we can use it. And you can see it goes to the research team. The research team does their thing. They pass it to the LinkedIn team, which is our doc writing team. They create a post, and this is the post. It's got emojis. I think it's dope. It's got hyperlinks. It's got hashtags. We love to see it. That is the multi-agent system. Again, if that was a little fast, we've got a precursor notebook you can work through in the repo as well. We're back to Dr. Greg.
All right, thank you, Wiz. Okay, yeah. Okay, guys, thank you for still being here with us. This has been a long morning, I'm sure, for all of you, and you're crushing it, powering through, so thank you. We do have a final session on MCP, so hopefully we're going to demystify some model context protocol for you right now, and Wiz is going to show you how to set up a very simple MCP server as well. So I'm going to get this screen shared right here, and we will be good to go. So, no, I want this one back. So stupid. Why can't I ask AI to help me with this? Oh, got that guy. Give me my screen. That's not for you. Okay. All right, so what we're going to do is, and so MCP is obviously a moving target today, but I'm going to give you the high levels on what you need to know. But quickly first, Lang graph. Oh my God. Lang graph and Lang Smith, we've got lots of content on it. Building multi-agent systems just means multiple agents. It means we're doing agentic reasoning. It means we have somebody deciding where to send people. It's tool calling all the way down. This is useful when we need to separate prompts, build conceptual models, or basically put JDs together. Okay. With all that in mind, with all that loaded into our models context, let's talk about MCP. Okay, TLDR. Use it for when you're building tools for agents, not humans. No, not humans. What do we mean by agents? Ho-ho! That's right, a system that can leverage or emulate reasoning to make dynamic decisions in an application flow. Now, what an MCP spec calls an agent is they call this an MCP client. So we want to use MCP when we're building tools for MCP clients, all right? We don't want to be using MCP as humans. We want our agents that we build to use MCP, all right? What is MCP? Oh, God. It's this, right? Let's look at some more quotes. It's the USB port. It's the protocol. It's the standard. It's the set of rules that standardizes how applications provide context to LLMs. To LLMs or to agents? Am I right? Am I right? No, it's definitely to agents, right? But wait, what's the difference? Oh yeah, we already talked about that. This is part of the difficulty as we keep stacking layers of abstraction. And you know, it's interesting to take this USB port idea and to try to understand it in this context, because USB-C is dope today, but like, was USB-C super dope when we first made it? Like, no, because you couldn't plug it into anything, right? So, and this has changed, you know, even since last week. How much stuff we can plug it into has changed since last week. So this is a key aspect of understanding MCP. You know, if we look at some of the information that we got from the press release that's that we might describe as kind of a slightly more useful is we have different types of information: content repos, business tools, dev environments. It's not exactly just tools. It's not exactly just resources. It's not exactly just artifacts. But it's kind of yes, it's exactly all of those things. Basically, you can anything you want your agent to have access to can live in an MCP server. And if you look at the spec, there's all sorts of lines like this. Whether you're building an AI-powered IDE, blah 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 blah. It's just very marketing-heavy stuff. This is the diagram. And the general architecture. It's the client-server architecture. And we want to think about the protocol as just the standardized way of dealing with this. For those of you that have this background, this is probably very straightforward, but the client is the thing that requests, okay, from the server. And the server is the thing that provides the service to the client, all right? So clients consume what servers serve. Clients consume what servers serve. So this is a great meme if you kind of understand application development. It's not so great if you don't, but let's zoom in a little bit here. The idea is that we're not going to use this as a client. We're not dining here ourselves in the MCP server cafe. We are building places for other, no, not people, agents to dine in our MCP server cafe. Okay, generally, that's what we're doing. And that's the important key takeaway. MCP returns, MCP compatible client responses. We can say stuff like this, right? What does that mean? Well, it means that I'll get something back and then it will figure out what the heck that means. It could be structured data, it could be unstructured data, and then it'll put it into the context window of the LLM. Because everything is about putting stuff into the context window of the LLM. It's returning stuff from the servers, and so the client is resolving the response so we can put stuff in context. It's model context protocol. It's the rules for governing how MCP clients, agents, consume and resolve what MCP servers serve. And it's for putting stuff in the context window. It's for putting stuff into our applications that leverage the design pattern of in-context learning. It's for putting stuff into our stack, whether it be a super simple, whether it be, let's say, in the cloud, whether it be on-prem, or whether it be agents. Now remember, importantly, it doesn't do anything. It's the rules for doing stuff, okay? It doesn't put stuff in context. It's the rules for putting stuff in context. It's a protocol. It's like HTTP. It's not as sexy and as hype as it sounds. There's two ways to use it, of course. We can use it as a client, or we can use it by exposing tools we have as a server. Wiz, turn it on. Just to be super clear on this point, will we be working on the server side or the client side? And is this changing today?
Yeah, so of course we'll be doing both, as one does not exist without the other, right? We won't be producing a client. We'll be using an existing client. In the case of the demonstration, we're going to use Cursor. There's many other clients you could use that come with this MCP out of the box, Cloud Code, and a myriad of others. We're going to produce or create the server side, so the MCP server today. This is only, basically which one you're doing depends on which part of the stack you're working on, right? If you are working on exposing tools through an MCP server, then you've got to be on the server side, of course. If you're working on producing an agent that consumes MCP servers, perhaps even ones that you have built yourself, then you'll be on the client side. Both of these have very simple implementations through basically every framework that exists. The idea is that, when you want to let others or other agents consume your tools, you're on the server side. and when you want to consume MCP, then you're on the client side.
Okay, so Wiz, we had an idea. It was like such a great idea. We're like, we're going to use this for our next cohort. It's going to be dope. We're going to build an MCP server. We're going to put all the stuff that people need to build, ship, and share production LM applications from 0 to Agent Hero and beyond into our MCP server. And then we were like, oh man, this week we got to build it. We went and you were like, you found something else, right? You found something called Context 7. And you realized, oh, we don't have to build it.
Yeah, so basically we had talked about building an MCP server that would provide up-to-date documentation for the entire course, and we were going to stitch that together, relatively straightforward build, but then we have this one, Context 7, which has 20,000 libraries and is going to be useful beyond the scope of the course into, I guess, whatever has documentation on the internet. Basically, this is just up-to-date documentation. Every time these sites are producing a new version, this is going to be updated to be kept in lockstep. So it means when you fetch, one of the classic problems with LLMs, when I ask an LLM for how to write React, right? If I'm just in like ChatGPT's web UI, it's going to give me like 7 versions ago, right? And all of the libraries that exist love breaking stuff all the time. And so this is going to make sure we're using the most up-to-date documentation, which is going to make sure that when it says to use a method, that method exists and hasn't been depreciated for 6 months.
That's right, that's right. Okay, so this basically is a thing we were going to do, and then we're like, oh, I was moving so fast somebody already did it. Dope, we'll use that instead. And so I think this is a key insight into any tool selection at any time when you're building any of these applications, is you need to pay attention to how things are moving and what you should be picking up in the future. Now we're going to move to a bit more of a toy problem for Wiz. Go ahead and just bang out the server for us. He's going to show a dice rolling example of a quick MCP server build. This is actually all it takes. We're going to do this in just a couple minutes here, and then we will wrap. Try to be right on time at 12:45 for those of you with places to go. All right, Wiz, over to you. Server time.
Yeah, it's time to build an MCP server. It is once again not that many lines of code. Oh man, if you love fast API, you're going to love this demo. Okay, so what is an MCP server? Well, basically, it's something that serves Model Context Protocol in a way that it can be consumed by an MCP client. Dr. Greg already told us, right, about the fact that this protocol does nothing. It's just a protocol. It's a handshake that 2 different sets of people can agree on and make sure that we're talking the same language, so you can transfer information back and forth, right? So the MCP server is the thing that actually delivers the endpoints that you can consume. Now, the way we've set this up is, again, if you use Fast API, this is identical to Fast API. We've just changed from Fast API to Fast MCP. You'll notice that we named the server MCP server because we're very creative. We create a Tvili client. That Tvili client, again, is web search, right? So we're going to have a number of tools exposed here. And you can see that we can expose tools. Our mcp.tool decorator is how we do that. We have our web search. Our web search is going to be a tool that does searching on the web. As you might have guessed, you can use doc strings to effectively communicate to the MCP client what tools you have and what they do. This is a simple example, and so the doc strings don't need to be very complex. If you are using more complex tooling, you'll want to, again, have the equivalent level of verbosity and clarity in the doc strings. This is what the client is going to look at when it's determining which tool to use and how, right? So easy enough for this application. We also have an MCP tool for dice rolling. Dice rolling is something that is close to my heart as an avid Dungeons and Dragons player, but more importantly, something that LLMs are really terrible at. People forget that these are very biased machines, and if you ask the LLM to flip a coin, it's going to be heads almost all of the time, depending on what the LLM you use is. Some LLMs use head over 80% of the time. Not very good. Not a good coin flip, right? Unless you know that and you're exploiting it. So we wanted to just be able to get some RNG here, and we also have boilerplate on how you can create your own tool. Once we've created this, it's very simple to use it. We go to our MCP client, and then we're going to add a new global MCP server. We're using Cursor. The language that you see in your MCP client might look different. If you were doing this through LangGraph, it would again look different. But all of the frameworks have something that is going to look similar to what we see next, which is pointing to this MCP server. This is the code that does this. Basically, this is just going to run it, and then the connection is going to be handled by the Cursor environment. You'll notice that it is indeed, though, running the server, right? So this is booting it up, as it were, right? So that it can be consumed by our client, which we're going to look at right now. So our MCP client is this guy. It's just an agent, right? In this case, it's the Cursor agent. You can see some past chats that I have, which I'll showcase. Can you roll the damage for 4th level Fireball? This is a number of D6s that need to be rolled, and you can see here that what it does is it finds the tool, roll dice, it passes in the correct call to the tool, it gets the result, and then it uses that as context to tell me what I rolled, and it seems happy with that roll, though it's incredibly average. We also have the web search tool, right? Did the Edmonton Oilers win the 2025 Stanley Cup? For those of you who already know, I'm sorry to bring it up again. For those of you who are going to learn this in this situation, I'm very, very sorry. The answer is indeed that they got trounced in the final game 5-1. Doesn't feel good, but at least it's true. Very up to date. And this is the idea, right? We want to augment this client, this thing we're using, with additional context, and we want to do it in a way that we can easily talk to each other. We didn't have to do any gluing here. We didn't have to tell the agent how to call the tool or why to call the tool. We just have to understand that it exists. In the dice example, we provide no context. We just say roll the damage, right? And it's like, that sounds like a dice roll to me, guy. And it does it. And this is the power of having a standardized format. Whether or not it keeps being called MCP is completely irrelevant. It's called that right now, so that's where we're going to talk about it. But having this protocol enables this. And again, this is a simple example, but you can imagine that this can extend to arbitrary levels of complexity. And with that, we'll pass you back to Dr. Greg.
All right, that's it. MCP right there, guys. Okay. Way to go, Wiz. All right, you want to talk more about MCP? We are available all day after. I'll tell you briefly the next thing. Okay, so that's building an MCP server. What we wanted to kind of take away from this again is the TLDR is use MCP when we're building tools for agents. In this case, the agent was the one that exists within Cursor. We're not building MCP servers. We're not using MCP servers as a client. Our agents are using them. It's still early. There's still lots to figure out, but things are getting figured out quite quickly. And what we want to do is we want to kind of wrap up here. Okay, so thank you everybody for joining us this week. Welcome to AI Makerspace. Okay, so for 10 years, I was teaching at university, and I saw that the only students that were succeeding in a 21st century workforce were those that were not only listening to cool stuff, but they were learning the cool stuff, they were using that cool stuff to build awesome things that they were excited about, and they were sharing the awesome things that they built with others that also liked the same cool stuff, okay? It wasn't degrees, it wasn't prestige, it wasn't pedigree, it was community, and it was making stuff that you really liked. The people that love what they do, they win. And at AI Makerspace, we're on a mission to create the world's leading community for people like all of you who are still here that want to build, ship, and share production LLM applications. Building, shipping, and sharing is the core of what we believe is important. Practical building, shipping, and sharing, the kind that creates ROI for people and companies. We try to give away everything we know, so you guys can give away everything you know. it's always more important to focus on what we don't yet know when we're all trying to embrace things like MCP and this LLM edge. You can find us every single week, on YouTube, live at 1 p.m. ET on Wednesdays. That's right, in 17 minutes. We have to go live on YouTube. So we're going to be doing that live from TMLS, and you guys can definitely watch locally if you and you want to hear our hot takes on what we saw this week at the conference. More generally, you can find us remotely, and in 2 weeks from now, we'll be covering like Llama Stack and Llama Guard, and we're always covering the latest and greatest tools. If you liked what you saw today and you want to really accelerate your ability to do it, we're coming up on cohort 7 of the AI Engineering Bootcamp. We're serving EU and North American time zones with our live courses, and we've got a lot of new additions, including many new agent frameworks, MCP, et cetera, et cetera. This week, because we also offer our course on platforms, some of them like Maven, sometimes run special discounts. You can actually get a discount on our bootcamp this week. It starts next Tuesday, cohort 7, and you can use discount code MAVEN100. Remember, we do offer really hands-on guidance. This was an insane amount of stuff we did today. We break it down step by step over 10 weeks so that you can get after it from there and do whatever it is that's aligned with your career goals and what you want to do next. And these skills are not going away anytime soon. They're the kind that you want to build. If you want to build them and ship them and share them with others, like these folks, this was released on YouTube last week. We've got about 12, 13K YouTube followers, and we release everything our students do live to our audience, as long as they, are up to date with the standards. You want to hear from some of our students, we've got lots of ways that you can do that as well. You want to say, forget that, I'm not spending any stupid money, I already spent enough on this conference. We feel you, okay, we feel you. Go ahead and just start for free, okay? Start building, shipping, and sharing for free with the AI Engineer Challenge, with your dev environment setup, with your first MCP server, with the stuff you learned here today, with TMLS Code 2025. Or go ahead and take just 15 hours out of your next couple of months and go through the core things, make sure you actually locked in on everything that you heard today. I'm sick of roadmaps that tell you to learn everything and then don't help you make any money. That's not what we're all about. We want you to create real value, capture some for your family, for your company. If that sounds like something you're interested in, definitely like and subscribe on YouTube and join our Discord community now. If you join it, you will get this amazing Richardson hat, this Build, Ship, Share swag, and hopefully you will wear it proudly. Lusk is available here with the QR code to join Discord on your way out, and we'd love for you to join us and get a hat and start building, shipping, and sharing today. Follow us on LinkedIn, follow us on X, follow the LLM Wizard on X too for the hot takes daily. And we really appreciate you guys' time. We're 1 minute over. Thank you so much, and we look forward to seeing you next year. Cheers, everybody.